Welcome to Earthology, a place where science drifts like a dream and every story feels like a tide returning home. If you're new here, take a moment to subscribe and join us as we journey through the quiet wonders of our planet and beyond. Tonight, we sink beneath the surface, into the hidden waters that flow beneath stone, beneath ice, beneath us all. Let the noise of the day fall away. Breathe. Listen. Somewhere in the dark, the ocean waits, not just around us, but within. This is the ocean beneath everything. Before anything else, there was silence. A vast, waiting silence in which no ocean yet breathed, no current yet moved, and no drop of water had yet touched the surface of a planet. In that silence drifted dust and light, the remnants of dying stars. From those remains, the seeds of everything were born. Within those seeds was oxygen and hydrogen, two elements that, when joined, would one day shape entire worlds. Long before Earth existed, the atoms of water had already been wandering the galaxy. They were forged inside ancient stars and released as those stars collapsed into their final luminous deaths. Water began as starlight, cooled and broken apart, waiting to find a home. When our solar system formed about 4.5 billion years ago, it was a swirling disk of dust and gas around a new sun. Near the center, where the heat was intense, metals and silicates condensed to form the rocky planets. Further out, where temperatures were lower, ice could exist, and there the giant planets and frozen bodies took shape. Water could not survive near the early Earth. It would have evaporated instantly, lost to the solar wind. Yet far away, it collected on comets, asteroids, and small frozen worlds orbiting beyond Jupiter. These were the cosmic couriers that carried water across the void. For millions of years, they drifted until gravity pulled them inward. Countless collisions followed. Ice struck molten rock. Vapor rose and fell as rain. The process was slow, violent, and endless. Each impact brought new water, which boiled, condensed, and fell again. Eventually, the surface cooled enough to allow that water to remain. The first true oceans gathered in the low basins of the young planet, shimmering under a dim red sun. They were acidic, filled with dissolved minerals, and constantly reshaped by volcanic eruptions and meteor storms. But they were there. Earth, once dry and silent, had begun to breathe. The ocean was never just a surface feature. From the beginning, it interacted with the rock beneath it. Water seeped into cracks and fractures, reacting with minerals, transforming the crust itself. These reactions created new materials, new gases, and new pathways for heat to escape. The ocean and the rock were partners, locked in an ancient exchange. That exchange continues even now, beneath every continent and seafloor. Scientists have studied tiny crystals called zircons, some of the oldest minerals on Earth. Within them lie microscopic traces of water, dating back more than 4 billion years, proof that liquid water existed on the planet almost from its birth. This means that water was not merely delivered later by comets, as once thought, but may have been present from the very beginning, locked inside the minerals that built the planet. It suggests that water and rock are not separate at all. They are two faces of the same creation. In the earliest ages, the planet was restless. The crust broke apart, folded, and sank into the mantle. Volcanoes erupted across a landscape of black glass. Through every vent rose steam, carbon dioxide, and sulfur. The air thickened with vapor. For millions of years, the rain never stopped. It fell with the force of stone, filling craters, carving valleys, and cooling lava fields. The sound of it must have been deafening, a constant roar on a world with no life to hear it. Slowly, the planet began to change color. The dull gray rock grew dark and wet, the basins filled. The first true seas formed, and the cycle of evaporation, condensation, and rain began its endless rhythm. Beneath those new oceans, hydrothermal vents opened like black chimneys along the ridges where tectonic plates met. superheated water poured out, rich with minerals. These vents became the cradles of chemistry, the laboratories of life before life. There, in the mixing zones between heat and cold, between rock and sea, the building blocks of biology began to form. Simple molecules linked together, powered by energy from the earth itself. Carbon, nitrogen, and phosphorus joined in fragile chains. Over time, those chains became something more, a pattern capable of storing information, replicating, and evolving. From the interaction of water, heat, and rock, the first cells were born. In this way, life was not something separate from the ocean. It was an extension of it, an expression of the same forces that had shaped the planet's crust. The first membranes that surrounded those early cells were made of the same minerals that coated the vents. Their chemistry mirrored that of seawater. Even today, the salt concentration inside human blood is remarkably similar to that of the ancient ocean. Every heartbeat is a pulse of that memory, echoing from the time when our ancestors were not yet animals, but currents in a warm, mineral sea. As the planet aged, the ocean deepened, and with it came the beginning of continents. The water that filled the surface also penetrated downward, carried into the mantle through subduction zones, where slabs of crust were forced beneath one another. This hidden migration of water continues today, unseen but immense. Every year, vast amounts of water are drawn into the Earth's interior, locked into minerals at depths no light can reach. And from those same depths, water returns, released through volcanic eruptions and hydrothermal vents. The water cycle we learn in simple diagrams, the one that moves between clouds, rivers, and seas, is only a fraction of the truth. The real cycle includes the mantle itself, an ocean buried hundreds of kilometers below us. Geophysicists have found evidence of this deep water through seismic studies. Waves from earthquakes travel differently through wet rock than through dry rock, revealing hidden reservoirs where water is bound within crystal structures. These reservoirs may contain as much water as all the surface oceans combined. It does not flow freely. It exists as ions trapped inside the mineral lattice. Yet its presence changes everything. It affects how rocks melt, how continents move, how mountains rise. Water is the lubricant of plate tectonics, the quiet architect of the planet's shape. Without it, the Earth's crust might have frozen solid long ago, locked in place like the surface of Mars. Because of water, our planet moves, breathes, and renews itself. This is the first ocean beneath everything, the hidden sea within the mantle, where water and rock merge into a slow geological dance. Every earthquake, every volcanic eruption, every grain of sand at the bottom of the ocean floor is part of that movement. When we look at the ocean's surface, we are only seeing the top layer of a far greater system, a network of water that reaches into the planet's heart. The next time you stand by the shore and feel the tide pull at your feet, imagine that motion extending downward, through the crust, through layers of ancient rock, until it meets the mantle below. There, water still circulates in silence, dissolving and reforming minerals, shaping continents from within. The surface and the deep are one continuous body, divided only by time and pressure. The ocean beneath is not a metaphor. It is real, and it holds the story of the earth itself. The ocean beneath is not a metaphor. It is a reality written into the crust itself, a slow heartbeat beneath the continents. Yet even this is only one layer of the water's story. For every drop that seeps downward, another begins its return. Magma rises from the mantle, carrying fragments of that hidden sea. When it reaches the surface, it cools, releasing vapor that feeds clouds and rain. In this way, the deep and the shallow oceans are linked in a single endless conversation. One exhales as the other inhales. If we could follow a single molecule of water through time, its journey would be longer than the history of civilization. It would begin as vapor rising from a black volcanic shore, drift into a storm, fall again as rain, slide through soil into an underground river, and then vanish into rock for millions of years. Eventually, through the slow recycling of tectonic plates, it would emerge again from a volcano, join the clouds, and start over. Each molecule is an ancient traveler, older than the first fish, older than the first tree. The ocean that covers our planet today is not the same ocean that once filled the primordial basins. It has been distilled, evaporated, and renewed countless times. Some of its water has been locked inside crystals for hundreds of millions of years. Some has fallen recently as rain. Every cup of water, every tear, every wave carries within it a mixture of ages, the very old and the very new. When we look at a horizon of open water, it feels eternal. But in truth, a sea is transient, always leaving, always returning. The currents we see are only the surface expression of a deeper motion, one that reaches down to the very boundary between crust and mantle. Scientists call this global circulation the deep water cycle, and it is as fundamental to the planet as breathing is to a body. Without it, there would be no continents, no atmosphere as we know it, and perhaps no life. For centuries, humanity thought the ocean was a boundary, the edge of exploration, the unknown. Only recently have we realized it is not the end, but the beginning. The ocean does not sit upon the planet like a layer of paint. It runs through it like blood through veins. From microscopic cracks in the basaltic crust, water penetrates downward in slow pulses, following heat. At spreading ridges, where new crust is born, seawater seeps through fractures and reacts with the rock, transforming it into new minerals. The water becomes part of the planet itself. This process can be witnessed at hydrothermal vents, where jets of mineral-rich fluid rise from the sea floor like underwater geysers. Around those vents, entire ecosystems thrive without sunlight, living on chemical energy alone. Tube worms, crabs, and shrimp gather in dense colonies, feeding on bacteria that convert sulfur and methane into organic matter. In those strange gardens of darkness, life reveals its true resilience. It does not depend on warmth from above, but on the heat of the Earth's interior. The discovery of these vent communities in the late 20th century changed our understanding of life forever. Before then, scientists believed all ecosystems ultimately relied on sunlight. But the vents proved another possibility: life born from the deep, fueled by water and rock instead of air and flame. It suggested that wherever such interactions occur, even on other worlds, life might emerge again. The same chemistry that began Earth's story could be repeating itself beneath the crust of moons and planets throughout the solar system. To grasp this idea, one must think of water not as a simple liquid, but as a force of transformation. When water meets rock at high pressure, it alters everything it touches. Olivine becomes serpentine, basalt becomes clay, metals dissolve and reprecipitate, heat is absorbed and released. Through these reactions, new environments appear, some capable of sustaining microbes that feed on hydrogen and methane. In this way, the deep Earth becomes a hidden biosphere, one that may extend for miles below the surface. In the past 2 decades, scientists drilling into the ocean floor have recovered samples from sediments more than 1 kilometer deep. To their astonishment, those samples were alive. Bacteria and archaea were found moving slowly within the pores of rock that had not seen daylight in tens of millions of years. Their metabolism is faint, their reproduction measured not in hours but in centuries. Yet they persist, forming what may be the largest and most ancient ecosystem on the planet. It is estimated that the biomass of this deep biosphere rivals, or even exceeds, that of all surface life combined. Imagine a living ocean hidden within the crust, an invisible network of cells feeding on minerals and heat. Every grain of sand at the bottom of the sea may contain 1,000 tiny lives. Every droplet that seeps into the basalt carries with it the potential for survival. The boundary between geology and biology dissolves. The planet itself becomes a living organism, its crust a skin, its mantle a beating core. To understand the depth of this connection, think of a single drop of seawater. Within it float microscopic plankton, some plants, some animals, some neither. They photosynthesize, breathe, and die, falling to the seafloor in an endless snow of organic dust. Over time, that dust becomes sediment, buried deeper until it turns to rock. The carbon within it, once part of living tissue, becomes trapped. When tectonic forces later melt that rock, the carbon is released again through volcanoes into the atmosphere, where it can be taken up by new life. Every living thing is built from atoms that have made this journey over and over again. This is why life and water cannot be separated. The ocean gave rise to life, and life, in turn, has reshaped the ocean. The balance of salt, the composition of gases, even the color of the water, have all been altered by biological activity. For billions of years, microorganisms have been cycling elements between sea and sky, maintaining a delicate equilibrium that allows complex organisms like us to exist. Consider the faintest sound in the deep ocean, the low hum of tectonic movement, the distant tremor of shifting plates. That sound is the voice of the planet's circulation, the whisper of water moving through stone. It is the same rhythm that beats within our veins. Each time our hearts pump, they echo the pulse of tides. Each time we breathe, moisture condenses and evaporates within our lungs, imitating the ocean's own respiration. We are not merely surrounded by water, we are shaped by it. Even within our bodies, water follows the same laws as in the sea. It seeks balance, moving from high concentration to low, dissolving salts, carrying heat, maintaining pressure. The movement of blood through capillaries is not unlike the flow of groundwater through porous rock, slow, continuous, and essential. When we speak of life, we are really speaking of organized water, structured around carbon and energy. Without water, the instructions of DNA could not fold into shape. Proteins could not move. Thought itself, electrical and chemical, would cease. In this way, every human being is an extension of the planet's hydrology. The ocean runs through us in miniature. It fills our eyes, cushions our cells, and surrounds the electrical signals of our nerves. When we cry, we return small fragments of that ancient ocean to the surface. When we exhale, invisible droplets of water rise into the air, completing their circuit through the world. The water we drink today has passed through countless forms. It may have fallen as rain on a prehistoric forest, frozen in a glacier for millennia, or flowed through the veins of a creature long extinct. In a literal sense, we drink the memory of everything that has ever been alive. Water does not forget. It carries traces of its history within its isotopic composition, its mineral load, its salinity. Scientists can analyze an ice core from Antarctica and read the record of climate stretching back hundreds of thousands of years. Each layer of frozen snow is a page in the diary of the Earth's breath. To imagine all of this is to feel a strange humility. The world we inhabit is not static, but fluid. Mountains rise and erode, but the water remains, endlessly reshaped. The Pacific that touches Asia today once flowed above what is now the Andes. The molecules are the same, only their paths have changed. The great ocean currents, the Gulf Stream, the Antarctic Circumpolar, the deep thermaline circulation are merely surface expressions of an older movement that began when the first rains fell on cooling rock. As the continents drift, as ice caps grow and melt, the ocean redistributes itself. Its surface area changes, but its essence endures. During ice ages, sea levels drop, exposing new lands. During warm periods, the seas rise, reclaiming them. Through these cycles, civilizations appear and vanish, but water continues its slow work of shaping coastlines and carrying heat around the planet. It moderates the climate, stores the sun's energy, and returns it as gentle warmth to the air. Every breeze across your face has passed over thousands of miles of open water before it found you. From orbit, Earth glows blue, not because of its land or sky, but because of light scattered through the ocean's upper layers. That blue is the color of depth, the color of reflection, the signature of water in motion. It is the same hue seen in the ice of distant moons and in the spectra of exoplanets where water vapor may linger. Wherever that color exists, there may be a form of the same story unfolding, a world breathing through water, waiting for life to emerge. In the next part of our journey, we will follow that color deeper into the secret networks beneath glaciers and deserts, where unseen rivers move through stone, and further still, to the frozen oceans hidden beneath alien skies. But before we go there, it is enough to know this. Every ocean is connected. The one on the surface, the one beneath the crust, and the one within us are the same continuous sea. To understand water is to understand connection. To follow its path is to see that nothing is truly separate. Not rock from rain, not body from planet, not life from the vast silence out of which it came. The ocean story does not end at the edge of the continental shelf. Beneath that invisible border, the seafloor drops away into darkness, and gravity draws water into every hollow space between grains of rock. There, slow rivers move through sediments that are neither fully solid nor fully liquid. Each particle of sand becomes a world of its own, hosting colonies of microbes that drift in and out of dormancy as nutrients pass by. Even here, hundreds of meters below the waves, the rhythm of tides can still be felt as a faint pressure, a heartbeat through stone. If a person could descend through these layers without being crushed, they would find that the ocean becomes less a body of water and more a network of veins. The pressure rises, the light vanishes, and water changes character. It seeps into basalt, fills microscopic fractures, and bonds to minerals that look dry but are saturated at the atomic level. What we think of as solid ground is actually a sponge that breathes over geological time. Every continent floats upon this invisible exchange. Inside this deep realm, time has a different meaning. Chemical reactions take centuries to complete. The distinction between living and non-living begins to blur. A molecule that once moved freely in the open sea might spend millions of years trapped inside a crystal, only to be released again through the heat of metamorphosis. In this endless cycle, nothing is ever truly lost. Water remembers the shape of every environment it has passed through, not as conscious memory, but as structure temperature, salinity, isotopic balance, all quietly recorded in its form. The oldest rocks on Earth still hold whispers of that memory. Within certain diamonds, tiny inclusions reveal traces of water that originated far below the crust, perhaps 700 kilometers deep. Those droplets are older than most continents. They prove that even in the mantle's crushing heat, water survives, changing its state, but not its essence. Under such pressure, it can become superionic half-liquid, half-crystal, where hydrogen atoms drift freely through a lattice of oxygen. It is water, yet unlike any we have ever touched, a substance that conducts electricity and glows faintly with internal motion. To think that oceans exist in such a state beneath us is to realize that the familiar blue surface is only an introduction. The Earth is not merely covered in water. It is soaked in it, infused from crust to core. This hidden water affects the melting point of rocks, the buoyancy of magma, and the way the planet's magnetic field behaves. Without it, volcanoes would erupt differently, mountains would rise more slowly, and perhaps the atmosphere itself would have taken another course. Above, the visible ocean continues its conversation with the sky. Evaporation lifts water into vapor, condensation shapes clouds, and precipitation returns it again. But every droplet that falls on land begins a second journey beneath the surface. Some of it trickles through soil to feed rivers. Some travels deeper, collecting in aquifers that stretch for hundreds of miles. In deserts, these underground seas are the only memory of ancient rains. When scientists drill into them, They sometimes find water that fell from the sky tens of thousands of years ago, sealed away during the last ice age. Each sample is a letter from a different climate, written in isotopes rather than ink. The largest of these subterranean stores lie beneath the great continental shields beneath North America, beneath Africa, beneath the steppes of Asia. Some are freshwater, others brackish, others saturated with dissolved minerals that could never support life at the surface. They move so slowly that a human lifetime would not be long enough to notice the change of direction. Yet over millennia, their motion carves caverns, feeds springs, and maintains the balance of surface ecosystems. Cities rise above them, unaware of the silent mass of water supporting their weight. The hydrologic cycle taught in schools shows clouds and rivers, rain and sea, but it omits this deep half of the picture. For every ocean that can be seen, there is another beneath it, diffused through rock and mineral. Together, they form a planet-wide system that stabilizes temperature and moderates the flow of carbon dioxide. When volcanoes erupt, they release gases once bound in deep water. When mountains erode, minerals react with rainwater to capture carbon again. The Earth exhales and inhales through these reactions, maintaining the fragile equilibrium that has allowed life to persist for billions of years. The chemistry of this cycle also hints at its antiquity. Ratios of deuterium to hydrogen in the ocean match those found in certain meteorites, suggesting a common origin. The water that fills our seas may have begun as ice grains in the protosolar nebula, captured by Earth during its formation. In this view, every ocean wave carries a trace of the interstellar medium. To stand by the shore is to stand at the edge of the cosmos itself. As the planet cooled and stabilized, the interplay between ocean and continent shaped the first climate. The sea absorbed heat by day and released it by night, smoothing extremes that would otherwise have torn the young atmosphere apart. This stabilizing effect continues today. The ocean stores 90% of the excess heat produced by modern global warming. It is both guardian and witness, absorbing our mistakes in silence. The deep currents that carry this warmth will take centuries to complete their loops. By the time the water now sinking in the North Atlantic returns to the surface near the Pacific, human civilizations will have changed beyond recognition. Yet the ocean will remember, because it holds the thermal history of every age within its depths. In the language of geology, water is a solvent, a transporter, a shaper. But in the language of reflection, it is something more, the mediator between fire and air, the element that allows opposites to coexist. It softens rock, but also gives it strength. It erodes and builds at once. Through water, the rigid planet becomes capable of change. Through that same property, life becomes capable of feeling. Our capacity for thought, for memory, for emotion, all depend on electrical signals that pass through a watery medium. Consciousness itself may be the most delicate ripple of this universal ocean. Some philosophers have imagined that water carries a kind of distributed awareness, not in the mystical sense of thought, but in its ability to connect. Wherever it flows, it links systems together, rock to sky, organism to organism, planet to planet. It is the thread that turns separate phenomena into a single tapestry. Without it, the universe would remain a collection of isolated solids drifting in vacuum. With it, there is continuity. The same molecule that once cooled a comet may now circulate in your bloodstream. The boundary between self and world dissolves. Think again of that blue light seen from space. It is not the color of emptiness, but of union. The photons scattered from the ocean's surface have traveled from the sun, through the atmosphere, through the sea, and back into the eyes of those who gaze upward. Every step of that journey passes through water, in one form or another vapor, liquid, crystal, ion. To see blue is to witness the path of light through matter that remembers its stellar origin. Beneath the Pacific, beneath the Atlantic, beneath every small lake and inland sea, the same pattern repeats: infiltration, transformation, return. Water moves downward, meets heat, changes phase, and rises again. The engine never stops. It is not a circle but a spiral, carrying the planet forward through time. Each turn of that spiral leaves new minerals, new sediments, new life. What we call evolution may be another expression of water's persistence, the tendency of molecules to find ever more complex ways to remain in motion. And so part one of this long descent ends where it began, with the recognition that water is not separate from Earth, nor from us. It is the substance of connection, the medium through which the universe learns to reflect upon itself. Beneath the continents, beneath the oceans, beneath our very thoughts, it continues to flow, silent and unbroken. When you next see rain slide down a window or watch a river bend around a stone, know that you are witnessing the visible edge of an invisible depth, a movement that began before time had meaning and will continue long after meaning is gone. That is the ocean beneath everything, the one that carries the memory of creation and the promise of return. The deeper you travel into the earth, the less the world resembles what we think of as solid. The crust, though rigid to us, bends and flows on long time scales. Between its grains, water moves like breath through lungs. It is not the same water that fills rivers or seas. It is altered by heat, by pressure, by the chemistry of stone. And yet, it remains water, carrying its quiet signature through every transformation. The hidden water cycle begins here, in the places no sunlight reaches. When rain falls upon a mountain, part of it sinks through the soil, passing roots and stones, trickling into crevices. Some of it returns quickly, as streams or springs, but some continues downward, deeper than any root, until it enters layers of fractured rock, where it may stay for millennia. Each droplet that disappears into this dark network begins a journey as ancient as the planet itself. Over time, that water reacts with the minerals around it, dissolving salts, picking up trace elements, and changing in composition. It becomes heavier, saltier, and often warmer. In certain regions, it mixes with gases rising from the mantle: carbon dioxide, methane, sulfur. These interactions form hydrothermal systems, vast and slow-moving arteries that connect surface and deep earth. In them, water is not a passive traveler, but a catalyst, shaping the planet from within. At mid-ocean ridges, where the crust splits apart and magma rises, seawater seeps into fissures. There it meets molten rock at temperatures above 400 degrees Celsius. Instead of boiling away, it transforms under pressure, carrying dissolved metals like iron, manganese, and copper. When it returns to the sea floor, it vents out as dark clouds rich in minerals, black smokers, they are called. Around these vents, life gathers in impossible abundance. Before their discovery, few imagined that anything could live in such darkness. The temperature gradient near a vent is extreme hot enough to melt wax at one point, freezing cold a few centimeters away. Yet this contrast provides energy. Chemosynthetic bacteria use it to drive reactions that turn inorganic molecules into food. From them, a web of life unfolds. Tube worms grow taller than a person, their blood bright red with oxygen-binding pigments. Crabs and shrimp graze on bacterial mats. Eels and fish move through the shadows. The ecosystem thrives without sunlight, proof that life's dependence on the surface is not absolute. The significance of these vent communities is more than biological. It is philosophical. They show that life does not need a sky to exist. It needs only water, energy, and the right chemistry. This realization reshapes our search for life elsewhere. It tells us to look not for Earth's reflection, but for its principle, the meeting of liquid and rock, the slow dance of elements in darkness. The hidden water cycle connects even the deepest parts of the planet to its living surface. At subduction zones, where one tectonic plate slides beneath another, vast amounts of oceanic crust are forced downward. The basaltic rock of the seafloor carries with it water locked inside minerals. As it sinks, that water is released, causing the overlying mantle to melt and form magma. Volcanoes rise above these zones, like exhalations. When they erupt, they return to the atmosphere the same water that once fell as rain. Thus the cycle closes, linking clouds to magma, rainfall to fire. To imagine the scale of this exchange is difficult. Every year, millions of tons of water are drawn into the mantle and returned again through volcanism. Some remains trapped for eons, held in crystal lattice of olivine and wadsleyite hundreds of kilometers deep. Geophysicists believe that within the transition zone of the mantle, between 400 and 700 kilometers beneath our feet, there may be enough bound water to equal all the surface oceans combined. This is the ocean beneath the ocean, invisible but real, sustaining the mobility of the crust itself. In certain high-pressure experiments, scientists have recreated these depths. When water-bearing minerals are squeezed to such extreme conditions, they change structure. Hydrogen ions slip between layers of oxygen, creating materials that are neither solid nor liquid. The discovery of superionic water part ice, part plasma suggests that deep within Earth, and even within other planets like Uranus and Neptune, water may exist in exotic forms that conduct electricity and shape magnetic fields. The blue glow of Neptune's storms, the auroras dancing over its poles, may owe their existence to oceans we cannot see. On Earth, the hidden water cycle sustains more than geology. It sustains life in places once thought sterile. The deep biosphere, as scientists call it, extends far below the surface, perhaps 5 kilometers beneath the ocean floor and 3 beneath continents. In those depths, microbial life persists in isolation, feeding on hydrogen and methane produced by reactions between water and rock. These microbes do not require sunlight or organic nutrients. They derive their energy directly from the planet's interior chemistry. When researchers drilled into deep sediments of the Pacific, they found living cells in layers 70 million years old. Their metabolism was so slow that each cell might divide only once every 1,000 years, but they were alive. In some boreholes, the concentration of cells was 10,000 per cubic centimeter, suggesting that the crust beneath the sea is not barren, but densely inhabited. These organisms form a vast, unseen ecosystem that may contain more carbon than all surface life combined. Such findings challenge our sense of what it means to be alive. We tend to associate life with movement, growth, and change, but in the deep biosphere, existence is measured in stillness. Energy is scarce. Reactions occur at the edge of thermodynamic possibility. Yet even in this near-suspended state, the continuity of life endures. The microbes maintain their structure, repair their DNA, and wait. They are the keepers of deep time, bridging eras in silence. In continental crust, too, water carries life into unlikely realms. In South Africa, 2 miles below ground in ancient gold mines, scientists discovered bacteria living in cracks filled with groundwater isolated for tens of millions of years. These microbes feed on hydrogen generated by radioactive decay of surrounding rock. Their world is completely sealed, lit only by the faint glow of instruments, yet they thrive in darkness, showing that life can arise wherever energy meets water, however faintly. The discovery of these subterranean ecosystems has reshaped planetary science. If life can survive miles beneath the Earth's surface, it might also persist beneath the ice of other worlds. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, both harbor global oceans beneath frozen crusts. Plumes of water vapor have been seen erupting from their surfaces, much like the black smokers of Earth's ridges. If hydrothermal vents exist there too, they may host their own forms of chemosynthetic life. The same principles apply: water, energy, and time. The hidden water cycle of Earth becomes a template for the cosmos. But on Earth, the hidden water cycle also shapes the surface in ways less visible but equally profound. Groundwater flow determines where forests grow, where deserts expand, where civilizations rise. The great rivers of history, the Nile, the Ganges, the Tigris, depend not only on rainfall, but on aquifers feeding them from below. When those aquifers are overdrawn, the land subsides and fertile plains turn to dust. In this sense, human history is bound to the same deep currents that move unseen beneath our feet. In recent decades, satellites have measured subtle changes in Earth's gravity field, revealing how water mass shifts across continents. These measurements show aquifers draining under the pressure of agriculture and industry. The loss is invisible day to day, but over years it becomes measurable. Whole regions sinking as their hidden reservoirs empty. The deep water that took thousands of years to accumulate can vanish in a single generation. The hidden cycle, though vast, is not inexhaustible. And yet, even as we draw upon it, the planet continues its quiet repair. Rain seeps downward, rivers infiltrate, minerals absorb and release. The motion never stops. Beneath deserts, beneath cities, beneath the floors of oceans, the dialogue between water and rock continues, oblivious to our awareness of it. If one could listen closely enough, perhaps through instruments more sensitive than any we possess, one might hear that dialogue as a slow vibration, a deep hum that resonates through stone. It would sound like silence to human ears, but to the planet it would be music, the rhythm of equilibrium restoring itself. Water has always been the element of balance. It moderates temperature, transports nutrients, and dissolves excess. In the human body, it maintains homeostasis, distributing minerals and removing waste. In the planet, it performs the same role on a grander scale. It is the solvent of order, the mediator of change. From another perspective, this hidden cycle can be seen as a vast metabolic system. The Earth breathes through the evaporation of oceans, sweats through rainfall, circulates through groundwater, and exhales through volcanic plumes. The pattern mirrors the physiology of living organisms because it obeys the same thermodynamic imperatives. Energy enters, work is done, entropy is released. In this sense, the Earth behaves like a living being, with water as its bloodstream. The deep biosphere reinforces this metaphor. Microbes feed on hydrogen produced by serpentinization, the reaction of water with olivine-rich rock. This process releases heat and sustains life without sunlight. The same reaction occurs naturally in hydrothermal systems on the ocean floor and may have been the spark for life as origin. Experiments simulating these conditions have shown how simple organic molecules can form spontaneously. Fatty acids assemble into membranes, amino acids link into peptides, and nucleotides into strands of RNA. Given enough time, chemistry begins to imitate biology. Perhaps the first cells emerged not on the ocean surface, but in the labyrinthine pores of submarine vents. Within those tiny cavities, gradients of heat and chemistry could sustain reactions long enough for self-replication to arise. If so, then life's first home was not the open sea, but the rock itself wet, porous, and warm. The ocean was born from stone, and life was born from the ocean. The boundary between the two is an illusion of perspective. Even today, that intimate connection continues. When rainwater touches basalt, it dissolves ions that nourish the sea. When volcanic gases bubble through the ocean, they feed plankton blooms that capture carbon from the air. Each act of erosion, each burst of eruption, is part of an ancient conversation between water and land. We live within the pauses of that conversation, brief intervals between movements too slow for us to perceive. The hidden water cycle reminds us that most of the planet's processes are invisible. We see the surface of things and call it reality, but beneath that surface lie layers upon layers of unseen motion. The sea hides its currents. The ground hides its rivers. Even the air hides its tides. If we could peel back those layers, we would see that everything flows. Stillness is only the limit of our senses. Beneath mountains, the same water that once fell as rain now lubricates faults, making earthquakes possible. Beneath glaciers, it forms channels that let the ice slide toward the sea. Beneath deserts, it gathers in aquifers that feed oases. Each hidden stream, each droplet sealed within stone, participates in the planet's living cycle. Nothing stands apart. To understand this is to see the world as a continuum rather than a collection of parts. The deep biosphere, the mantle ocean, the atmospheric vapor, they are expressions of a single system, bound by gravity and energy. In that unity lies the secret of stability. The ocean does not simply cover the world, it integrates it. As scientists map the subsurface with seismic waves and isotope tracers, they are uncovering a vision of Earth that is more fluid than solid, more alive than inert. They find that the boundaries between spheres, hydrosphere, lithosphere, biosphere, are porous and shifting. Water moves across them effortlessly, erasing distinctions. When the first astronauts saw Earth from orbit, they called it the blue marble. What they saw was not just water, but movement, reflection, and interconnection. From that distance, the continents are minor interruptions in a global sea. The true shape of the planet is defined by water, not land. In the stillness of deep time, water will continue to sculpt the planet long after human traces fade. Continents will merge and separate. New mountains will rise. The hidden water cycle will persist, carrying memory through metamorphic stone. The deep biosphere will adapt to new chemistries, as it always has. And the surface ocean, breathing in rhythm with the mantle below, will continue its slow conversation with the sky. This is the ocean beneath everything, a system that unites weather with geology, biology with time. It is the unseen engine of change, the silent force that keeps the Earth from ever truly standing still. The ocean beneath everything, the system that unites weather with geology, biology with time, is not a static network. It changes shape as the planet breathes. To see it clearly, one must slow thought until centuries seem to pass in a heartbeat. Only then can we perceive how water moves through the architecture of the world. Deep within the crust, water and heat meet in narrow corridors that no human has ever seen. These passageways form where tectonic plates grind against one another, or where magma intrudes into older rock. Under pressure, water becomes both a solvent and a sculptor, dissolving minerals, creating veins of quartz, calcite, and ore. When it cools, those minerals precipitate again, filling fractures with crystalline memory. Every mountain on Earth carries such veins, traces of ancient water frozen in stone. Some of these hydrothermal systems remain active today. Beneath Iceland, New Zealand, and Yellowstone, water circulates through deep faults, rising again as geysers and hot springs. The steam that bursts into air is only a tiny fraction of what moves below. Most of the water remains hidden, locked in an endless loop of descent and return. Scientists studying these systems have found that even at depths where the temperature exceeds 300 degrees Celsius, microbial life persists. Bacteria cling to mineral walls, feeding on hydrogen and sulfur, thriving in conditions that would destroy almost any surface organism. These microbes do not merely survive. They alter their environment, accelerating chemical reactions that would otherwise take geological timescales. Through them, the line between biology and geology dissolves a little more. The presence of life in such extremes has expanded the known boundaries of habitability. Once, we thought that the biosphere ended at the soil's edge. Now we know it extends far below, wherever water can penetrate. The deep biosphere is not an anomaly. It may be the dominant mode of life on this planet. Most of its inhabitants will never see sunlight, never experience seasons, yet their metabolic signatures shape the chemistry of the oceans above. The methane they produce seeps upward through sediments, feeding other microbes that, in turn, influence the carbon cycle of the atmosphere. Every breath we take contains a trace of gases processed by invisible colonies kilometers beneath us. There is a strange comfort in this thought that the surface world is not alone, but rests upon a foundation of living matter. The forests and rivers, the deserts and clouds, are just the visible skin of a much larger organism. We live on the crust of something alive. This understanding is not new. Indigenous traditions across the world have long described the Earth as a being rather than an object. Only recently has science provided the evidence to make that vision tangible. The discovery of subsurface microbes, the movement of isotopes through rocks, the whisper of seismic waves through water-rich mantle zones. The myths were not wrong. They were simply poetic descriptions of what we are only now learning to measure. Far below the ocean floor, where sediments turn to shale and basalt, water continues its slow circulation. Some of it originates from the surface, carried downward through fractures. Some is generated in situ, formed by reactions between hydrogen and oxygen released from minerals. This means that even in total isolation, where sunlight and surface water never reach, the planet can create new water of its own. Hydrogen freed from iron combines with oxygen from silicates, producing fresh HO under heat and pressure. Water, it seems, is not only the solvent of life, but also its renewable foundation. It can be born again from the very rocks that it once transformed. If we could descend into one of these deep aquifers, the experience would be alien. The darkness would be absolute, yet the air, if we could call it that, would shimmer with heat. The walls would weep mineral-rich brine, heavy with dissolved elements. The scent would be metallic, the taste acidic. Each droplet would carry the fingerprint of its journey, a record of temperature and time encoded in its chemistry. It would be like walking through the memory of the planet. Every so often, pressure builds within these confined reservoirs until the system finds release. A vent opens on the seafloor. A geyser erupts on land. A volcano exhales steam. The sudden violence of these events is balanced by their slowness on a planetary scale. What we experience as eruption is, in truth, only an exhale in an eons-long breath. The same water that fuels volcanic explosions also cools magma chambers, moderating their behavior. Without it, eruptions would be far more catastrophic. Even destruction on Earth is softened by water's presence. In this way, water plays both the role of creator and destroyer. It melts rock to form magma, then quenches that same magma into new stone. It erodes mountains, but the sediment it carries becomes the foundation of future lands. It destroys form, but preserves essence. This duality mirrors the cycles of life and death that occur within the deep biosphere. Microbes die, their bodies compressed into layers of organic carbon, which over millions of years become fuel coal, oil, natural gas. When humans burn that fuel, they release ancient sunlight stored by long-vanished organisms. The smoke rises, alters the climate, and returns as rain, completing another turn of the endless wheel. Some scientists have described Earth as a water machine, a self-regulating system that maintains balance through feedback loops. If the surface becomes too cold, volcanic outgassing increases, adding greenhouse gases. If it grows too warm, chemical weathering accelerates, drawing carbon back into the crust. Water is central to both processes. It dissolves carbon dioxide in rain, forms carbonic acid that eats away at rock, and carries the resulting ions to the ocean, where they form carbonate minerals that sink to the sea floor. There, subduction returns them to the mantle. This cycle, spanning hundreds of thousands of years, stabilizes the planet's temperature and prevents the runaway conditions that sterilized Venus and froze Mars. The hidden water cycle is not only geological, it is climatic. It ensures that Earth remains a cradle for life. To observe this machine at work, one can look to Iceland, where glaciers, volcanoes, and the ocean meet. Meltwater from the ice flows into geothermal fields, absorbing heat, and emerges as steam that powers turbines. The same water falls again as snow, repeating the cycle each year. On human timescales, it seems rapid. On planetary timescales, it is a heartbeat. Each cycle releases energy drawn from the planet's core, a reminder that beneath every landscape, water and heat are entwined in quiet collaboration. In deserts, the hidden water cycle takes a different form. Beneath dunes and salt flats lie ancient lakes, long vanished from the surface, but preserved underground. The Nubian sandstone aquifer in Africa holds water that fell as rain hundreds of thousands of years ago, when the Sahara was green. In the American Southwest, fossil aquifers preserve the memory of the last ice age. They are finite, slow to refill, and yet they reveal how the planet stores its past. Every region carries its own archive of water, written not on paper, but in isotopes and salts. To study them is to read history through chemistry. The hidden biosphere extends into these dry realms as well. Even in hyper-arid deserts, microscopic life persists within porous rock. Cyanobacteria and fungi form communities just below the surface, protected from radiation but close enough to capture traces of moisture. They enter dormancy for years, waiting for a single rainfall to awaken them. When the rare storm comes, the desert blooms overnight, proof that water's touch is never wasted. It is as though the entire landscape is holding its breath between drops. This patience is water's greatest lesson. It does not hurry, yet it achieves everything. Over millions of years, it can move mountains, carve canyons, shape continents. It is both sculptor and storyteller, recording each change in layers of sediment. Every ripple preserved in stone was once a living motion, a small fragment of a wave that touched the world and left its impression. Geologists read these ripples like words in a forgotten language, reconstructing ancient climates and vanished seas. The record is incomplete, but it speaks of continuity. If the Earth were to lose all surface water tomorrow, the hidden cycle would continue for a time. Steam would rise from the mantle. Brines would circulate through the crust. The deep biosphere might persist for millions of years after the surface had become sterile. This possibility teaches us something profound about resilience. Life, once begun, is difficult to extinguish. As long as water can move, some form of it will endure. The same logic applies beyond Earth. When scientists study Mars, they look for minerals that form in the presence of water clays, sulfates, hydrated salts. These are the fossils of flow, evidence that the red planet once shared our blue inheritance. On Europa and Enceladus, plumes of water vapor reveal subsurface oceans kept liquid by tidal heating. These distant worlds mirror our own hidden water cycle, operating under different suns. They are reminders that Earth's story is not unique, but part of a universal pattern. Wherever there is water, there is potential for life. The hidden water cycle, then, is not confined to our planet. It is a cosmic principle, linking geology and biology across worlds. It shows that water is not simply a chemical compound, but an organizing force, capable of turning matter into system, chaos into rhythm. On Earth, it shaped continents and carved valleys. Elsewhere, it may be shaping the future homes of life. Back on our own world, the unseen movement continues even now. Beneath the calm of the ocean floor, thermal currents mix nutrients that rise slowly to the surface, feeding plankton blooms that feed fish, that feed birds, that feed us. The chain of dependency is unbroken, and at its base lies the same invisible cycle that moves through stone. We breathe because microbes beneath our feet process elements we will never see. We live because the deep earth never stops turning water into motion. To stand by the sea and watch the horizon is to see only the top of a vast, breathing organism. The waves that reach the shore are the exhalations of deep time. Beneath them, through kilometers of rock, water continues its slow descent, carrying the memory of every age. The hidden cycle does not ask for recognition. It simply is. The hidden water cycle is vast beyond comprehension, yet within it, Each molecule follows a simple rule: to move from where it is dense to where it is free, to find equilibrium. This law governs not only oceans and clouds, but everything that lives. Balance through movement, stillness through flow. Even the air carries traces of the deep. When volcanic gases rise, they carry molecules of water released from subducted crust water that once fell as rain on a forest, now turned to stone. It is possible that the mist you feel on your face today once lingered in the lungs of a dinosaur, once froze in a glacier that has long since melted, once lay silent in the mantle for 1 billion years. Water's story is not a circle, but a tapestry, each thread crossing countless others before returning to where it began. In the deep biosphere, that tapestry is woven slowly. Life moves in glacial rhythms, yet it adapts to pressures and temperatures that would crush any surface creature. Some microbes survive at over 100 degrees Celsius, clinging to mineral grains. Others thrive in the freezing brines of the deep ocean, where salt concentration would desiccate most forms of life. Each has evolved a unique chemistry: proteins that remain flexible at extremes, membranes that do not rupture, DNA repair systems that function in near total darkness. These adaptations hint at an ancient lineage. Perhaps the first life on Earth emerged in similar conditions, deep below the surface, safe from meteor bombardment and ultraviolet radiation. If so, then the deep biosphere is not just a curiosity, it is a window into our own origin. Within those hidden cells may lie the genetic echoes of the planet's first breath. When scientists extract DNA from these subterranean organisms, they find sequences unlike anything on the surface. Many belong to entirely new branches of the tree of life, the so-called microbial dark matter. Each discovery expands the boundaries of biology, showing that the known world is only a fraction of what exists. Even after centuries of exploration, most of Earth's species remain unnamed, unseen, and thriving in darkness. The chemistry that sustains them is elegant. Water interacts with minerals, such as olivine, producing hydrogen gas. Carbon dioxide from volcanic sources dissolves in this hydrogen-rich environment, forming methane and organic acids. These compounds become food for microbes, which in turn generate waste products that feed other organisms. The cycle closes upon itself, a miniature version of the larger planetary metabolism. Nothing is wasted. Every reaction feeds another. In some regions, deep living bacteria form biofilms that coat rock surfaces like living varnish. They alter the color of the stone, influence its magnetic properties, even change how seismic waves travel through it. In a sense, they rewrite the geology from within. The crust is not inert. It is being continuously modified by life. Over millions of years, such microbial activity could determine how ores form, how mountains weather, how continents shift. The planet is not merely inhabited, it is inhabited through and through. If one could listen to this process, it would not sound like water rushing, but like a slow, resonant vibration. The entire Earth hums with it, a sound created by waves moving through rock and fluid together. Seismologists can detect this background hum, a continuous resonance even in the absence of earthquakes. It is the voice of the planet's circulation, the sound of deep water shifting. The deep biosphere also acts as an archive of environmental change. When surface conditions fluctuate, when ice ages come and go, when atmospheres thin or thicken, these hidden ecosystems persist, preserving lineages that might otherwise vanish. In their genetic code lie records of past climates, chemical compositions, and perhaps even catastrophes. Studying them allows us to trace how life responds to planetary upheaval, how resilience is built into the fabric of existence itself. At times, this hidden world briefly reveals itself. An earthquake cracks open new faults, releasing deep gases that rise through the sea. A volcanic eruption brings ancient water to the surface as steam. In those moments, the boundaries between above and below blur. The deep ocean breathes out, the sky inhales, and for a brief instant, the planet's unity becomes visible. The pattern repeats at every scale. Beneath Antarctica, subglacial lakes lie sealed under kilometers of ice, cut off from sunlight for hundreds of thousands of years. Yet when researchers drilled into one of these lakes, they found living microorganism cells dividing in near-freezing brine, metabolizing nutrients from the rock below. These lakes are both ocean and time capsule, preserving a record of past atmospheres and bubbles of trapped gas. They are a reminder that even under crushing pressure, where darkness reigns absolute, water still nurtures life. In Greenland, too, water carves channels beneath the ice, lubricating its slow journey toward the sea. The movement of glaciers, though seemingly solid, depends entirely on liquid water at their base. Without it, the ice would fuse to the bedrock and halt. With it, glaciers flow like rivers of stone. They sculpt valleys, transport sediments, and feed the ocean with mineral dust that nourishes plankton blooms thousands of miles away. The connection is subtle but complete. Ice, rock, sea, and life bound by water's patient hand. All of this hydrothermal vents, mantle hydration, subglacial lakes, aquifers, composes a single network. A hidden water cycle is the planet's circulatory system. It links the fiery core to the frozen poles, the ancient past to the living present. It has shaped continents, moderated climate, and sustained life in forms we are only beginning to understand. When we trace the path of water through this vast interior, we are not merely studying geology. We are witnessing the continuity of being. The same molecules that fell as rain billions of years ago are still here, still moving, still learning the contours of the world. They have seen continents collide, species emerge, civilizations rise. They have flowed through everything, and they will continue long after we are gone. To grasp this is to recognize a quiet truth. The ocean beneath everything does not end where rock begins. It flows through the planet as thought flows through mind, invisible yet essential. It binds the living to the inert, the surface to the core. And in its endless motion, it carries the message that nothing truly stands apart. When future explorers travel to other worlds, they will search not first for air or soil, but for water. They will listen for its resonance in the vibrations of ice, its spectral fingerprint in the light of distant suns. Because where water is found, the possibility of connection exists. And connection, more than chemistry, is the essence of life. So the hidden water cycle continues silently, faithfully, endlessly. Beneath every step you take, beneath every mountain and ocean, beneath every heartbeat, it flows. It is the unseen river that sustains the planet's balance and reminds us that all things, no matter how still they appear, are in motion together. Beneath the white silence of the polar regions, oceans move unseen. They do not glimmer in sunlight or crash upon shores. They whisper beneath the weight of ice, ancient and slow. Antarctica, from above, appears frozen and lifeless, a vast continent of compressed snow. But beneath that stillness lies a labyrinth of liquid water, hidden between ice and rock. Scientists first suspected these hidden seas from the way the ice moved. It flowed more quickly in some regions, almost as if floating. Radar pulses sent into the glacier returned echoes that suggested layers of water below. What they found astonished them. Beneath more than 3 kilometers of ice lay hundreds of subglacial lakes, connected by channels that can drain and refill like tides. The largest of these, Lake Vostok, is roughly the size of Lake Ontario and may have been sealed off from the surface for millions of years. The water there is not ordinary. Pressurized by the weight of ice and warmed slightly by geothermal heat, it remains liquid despite temperatures below freezing. It is saturated with oxygen and minerals leached from the bedrock below. In this dark, enclosed world, life endures in microscopic forms bacteria, adapted to extreme pressure and chemical scarcity. When a Russian team drilled carefully into the lake, they found traces of DNA belonging to previously unknown species. Some sequences resembled those found near deep-sea vents. Others had no match on record. What lives there has never seen the sky. Its energy comes not from sunlight, but from reactions between rock and water, between oxygen and minerals, carried in by slow melt. Each cell divides perhaps once in a century, its metabolism tuned to near silence, and yet it lives. These subglacial lakes are not isolated oddities. They are part of a vast hydrological network beneath the Antarctic ice sheet. Water melts at the base, flows through tunnels, and refreezes elsewhere, lubricating the ice above. This system affects how glaciers move, how ice streams accelerate toward the coast, and how the continent contributes to rising seas. In this way, even the deepest frozen places are in motion. The solid white of the map hides a liquid heart. In Greenland, a similar story unfolds. Beneath the ice cap, meltwater generated each summer seeps downward through crevasses until it reaches the base, forming channels that snake toward the ocean. These channels, invisible from above, determine how fast the ice sheet flows. When they widen, glaciers surge. When they close, the ice slows. The rhythm of these hidden rivers shapes coastlines thousands of kilometers away. Water in these depths behaves differently from that at the surface. It dissolves rock, widening cracks into caverns, shaping entire landscapes from below. Over eons, this process creates karst, terrain of sinkholes, caves, and underground rivers. The limestone caves of Southeast Asia, the cenotes of the Yucatan, and the subterranean channels of Croatia and Slovenia all owe their existence to this quiet erosion. In such places, the boundary between land and water is in constant flux. A river may vanish into stone and emerge again miles away, changed but unbroken. Inside these caverns, the air is heavy and cool, filled with the slow dripping of mineral-rich water. Stalactites grow from the ceiling, stalagmites rise from the floor, and where they meet, they form columns that resemble frozen pillars of time. Each droplet that falls carries a trace of calcium carbonate, and with every drop, the cave evolves. Over thousands of years, these formations record subtle shifts in climate and rainfall, much like the layers of ice in polar cores. Scientists study their isotopic ratios to reconstruct patterns of drought and monsoon. In this way, even the silent growth of stone becomes a chronicle of water's passage. Yet beneath the caves lies an even deeper domain, aquifers so pressurized that they can drive water upward through rock, creating artesian wells. In some regions, these natural fountains reach the surface unaided, forming oases in the midst of deserts. The ancient city of Damascus, the settlements along the Silk Road, and countless forgotten villages owe their existence to such springs. Civilizations have always flourished where hidden water meets light. Beneath every garden and temple lies the same secret, a flow from darkness to day. In recent years, technology has revealed that these underground systems are far more extensive than once believed. Using electrical resistivity imaging and gravitational measurements, scientists have mapped networks of groundwater that span continents, connecting mountain snowmelt to coastal springs. The Earth's crust, it seems, is less a solid foundation than a permeable shell, its pores filled with motion. Even beneath the ocean floor, water percolates through sediments and basaltic rock, circulating between ridges and trenches. This slow exchange carries heat and nutrients, influencing the chemistry of the entire sea above. The scale of these processes is almost incomprehensible. The total volume of water stored underground in pores, fractures, and minerals may rival that of the visible oceans. Most of it is too deep or saline for human use, yet its existence stabilizes the planet. It cushions tectonic stress, distributes geothermal heat, and provides habitats for microbial life that may outnumber all surface organisms combined. Within this dark hydrosphere, life takes on strange forms. In Europe's Lechu Gwila Cave, researchers discovered bacteria that had been isolated from the surface for 4 million years. When exposed to modern antibiotics, they resisted nearly all of them, having evolved natural defenses in isolation. In the gold mines of South Africa, microbes survive in groundwater warmed by radioactive decay, feeding on hydrogen and sulfur. Some of these lineages are so distantly related to known species that they may represent entirely new domains of life. The deeper scientists search, the more they find that life has always been there, waiting. These discoveries echo those made beneath Antarctica's ice. They reveal a continuum, from subglacial lakes to deep aquifers, from hydrothermal vents to mantle pores. Water supports life wherever it flows. The same chemical reactions that sustain bacteria miles below ground may operate on other planets, hidden beneath crusts of rock or ice. Every discovery of subterranean life on Earth expands the map of where life might exist elsewhere. But the subterranean ocean has another role. It serves as the planet's memory. When volcanic gases dissolve into groundwater, they form carbonic acid that reacts with rock, storing carbon in the crust. When the crust subducts, that carbon returns to the mantle, only to be released again in volcanic eruptions. Through this cycle, water and carbon weave together the story of Earth's atmosphere. The air we breathe owes its balance to reactions occurring far below, invisible yet vital. In human history, the presence of hidden water has guided exploration, migration, and faith. The earliest agricultural societies developed around springs that never ran dry. In the deserts of Persia, engineers built qanats, underground channels that tapped distant aquifers and delivered water to fields through gravity alone. In Egypt, the annual flooding of the Nile was revered as a divine rhythm, a visible expression of the invisible flow beneath. Everywhere, people intuited what science would later confirm, that the earth itself circulates, that water moves through its body like spirit through flesh. In myth, too, the idea of subterranean water recurs. The Greeks spoke of the river Styx, flowing beneath the world as a boundary between life and death. The Sumerians imagined the Abzu, a primeval ocean beneath the land, source of all creation. In Hindu cosmology, the underworld is supported by 7 subterranean rivers. Across cultures, the image is the same, a deep water that connects realms, unseen but omnipresent. What ancient poets described as divine intuition now aligns with geological fact. The world truly does rest upon an ocean, not above, but within. Even our cities, modern and bright, are shaped by this unseen element. Subways follow the paths of old rivers. Foundations are anchored in aquifers. Every building that rises into the sky depends on the water beneath its feet. And every life that unfolds within those buildings depends on the same molecule that moves through stone, that fills clouds, that once drifted through the stars. To think of water in this way is to feel a quiet awe. It is not simply a resource, but the medium of continuity, connecting the ancient with the modern, the surface with the core. The hidden oceans of Earth, beneath ice, beneath rock, beneath thought, remind us that the planet is more fluid than we imagine. It moves in ways too slow for our senses, yet through those movements, everything we know is sustained. The subterranean ocean does not roar. It murmurs, it seeps, it hums in frequencies felt rather than heard. Its motion underlies the pulse of rivers and the swell of tides. It links continents, carries memory, and blurs the boundary between the living and the inanimate. To listen for it is to listen for the heartbeat of time itself. The subterranean ocean continues to move long after surface waters fall still. Beneath the weight of continents, water migrates through microfractures no wider than a strand of hair. It travels so slowly that a single meter of movement can take centuries. Yet this slow seepage is what shapes the Earth's long memory. Every mineral vein, every cavern, every grain of sand that carries a sheen of moisture is part of that persistent migration. To study such depths, scientists listen rather than look. They send vibrations through the ground and read the echoes. In those echoes are stories, layers of clay, pockets of brine, voids that once held rivers now turned to stone. The data shows that water exists at almost every depth we can measure. Even miles beneath mountains, hydrogen and oxygen linger, bound in crystal lattice, waiting for the right conditions to flow again. The deep earth is not dry. It breathes moisture the way a lung breathes air, exhaling slowly through faults and fractures. In certain volcanic regions, this breath becomes visible. Iceland's geysers, Japan's hot springs, and Italy's fumaroles are places where groundwater meets magma. The water flashes into steam, carrying minerals upward. The air smells of sulfur and salt. The rocks are stained red and white by evaporated metals. For those who live nearby, these places are sacred and dangerous, doorways to the planet's interior. They remind us that water and fire, though opposite in nature, are bound by necessity. Without water, volcanoes would erupt differently, more violently. Without heat, water would stagnate. Together they create the planet's rhythm of renewal. The same balance shapes life in subterranean rivers. In Mexico's Yucatan Peninsula, the cenotes, deep sinkholes filled with clear groundwater, form a network that once supplied the Maya with fresh water. They also served as ceremonial entrances to Xibalba, the underworld. Modern divers exploring them have discovered entire cave systems stretching for hundreds of kilometers, where light filters through like liquid glass. In these depths, stalactites hang like frozen rain, and fish without eyes glide silently through blue tunnels. These creatures have adapted completely to darkness, losing pigmentation and vision, gaining sensitivity to vibration and pressure. Each one is a living record of isolation, evolution written in pale flesh. Similar systems exist elsewhere, in Slovenia's karst rivers, in the blue holes of the Bahamas, in the flooded caves of the Philippines. Each is a gateway to the world below the world, where water moves unseen, connecting landscapes we once thought separate. Beneath every forest, every mountain range, there are such veins, corridors through which the planet circulates. What emerges from these explorations is a sense of continuity. The subglacial lakes of Antarctica, the groundwater of deserts, the limestone caves of the tropics, all are expressions of the same process. Water flows downward, finds pressure, finds heat, and returns. The scale changes, the setting changes, but the principle remains. The Earth's true geography is internal. Its continents are not islands, but membranes through which the ocean passes in endless cycles. At the edge of science, the boundary between geophysics and philosophy begins to blur. Some researchers speak of the deep Earth as a hydroplanet, one that contains as much water within as upon its surface. Others speculate that the mantle itself might act as a vast reservoir, seeding volcanoes and sustaining the long-term balance of the oceans. If this is true, then the sea is not a surface phenomenon at all. It is a manifestation of the planet's interior structure, an outward sign of an inward ocean. We can glimpse this hidden connection through volcanic glass found on the seafloor. Trapped within these fragments are bubbles of water released from magma, fingerprints of the deep cycle at work. When measured, they reveal that the composition of seawater has remained remarkably stable for hundreds of millions of years. Despite tectonic upheaval, erosion, and climate shifts, the ratio of salts and elements stays within narrow bounds. It is as if the planet itself regulates the ocean, drawing upon its inner stores to maintain balance. This constancy is not accidental. It is the product of water's endless patience. Each drop that falls as rain will eventually find its way to the sea, to the rock, to the mantle, and back again. The journey may take days or eons, but the result is equilibrium. Through that slow rhythm, the planet sustains the conditions for life. In caves and aquifers, this rhythm is echoed in miniature. Water drips from stalactites in steady intervals, seconds, minutes, hours. The sound is hypnotic, like a clock made of stone. For those who enter these caves, time seems to stretch. The drip is both ancient and immediate, a reminder that every moment is a continuation of motion begun long before memory. Beneath the Himalayas, the world's largest mountain chain, groundwater descends to depths exceeding 10 kilometers. There, under immense pressure, it reacts with rock to produce hydrogen, feeding microbial communities that thrive in total darkness. These bacteria play a subtle role in the planet's carbon cycle, converting inorganic gases into organic compounds that eventually return to the surface through seepage and erosion. The connection between the highest peaks and the deepest aquifers is intimate. Snowmelt feeds rivers, rivers feed plains, and from the plains, water returns below to begin again. As the climate changes, the hidden water systems respond. Glaciers melt, altering the pressure on aquifers. Sea levels rise, forcing salt water into freshwater reservoirs. In some coastal regions, ancient groundwater is being displaced by the encroaching sea, blending two domains that were separate for millennia. The result is both a challenge and a reminder that all boundaries drawn by humans are temporary. The planet does not recognize them. Scientists now use satellites to measure these subtle shifts. The GRACE mission, which observes variations in Earth's gravity, can detect the mass of water moving beneath ice sheets and continents. Its data shows the breathing of the planet, ice melting, aquifers draining, monsoons refilling them again. What looks to us like change or crisis is, in the grander view, the continuation of a long conversation between water and world. Even in places where humanity has overreached, where wells run dry, where rivers vanish, the deeper system endures. It may take thousands of years, but water will find its path back. The planet is patient. It has survived greater transformations than ours. The hidden ocean waits, adjusting, adapting, reclaiming balance over spans of time beyond imagination. In this patience lies a kind of wisdom. Water teaches through endurance. It shows that movement and stillness are not opposites, but phases of the same cycle. It reminds us that what appears empty may be full, that what seems motionless may be flowing inwardly. The glaciers of Antarctica, the caverns of Yucatan, the aquifers beneath deserts, all whisper the same truth: persistence through transformation. And so, when we speak of the ocean beneath everything, we are speaking not only of geology, but of continuity itself. Beneath every surface, there is depth. Beneath every stillness, motion. The unseen rivers and lakes, the hidden seas beneath ice and stone, are the connective tissue of the earth. They bind its systems together in silence, ensuring that even in the absence of life, the potential for life remains. In the centuries to come, as explorers reach farther into the solar system, they will find this same pattern again: oceans beneath ice, brines beneath dust, vapor beneath crust. The earth has been their teacher. It shows that to sustain life, a planet does not need sunlight alone. It needs depth, pressure, and water's unyielding will to flow. Here, under our feet, that will continues. Every mountain is a wave slowed by stone. Every glacier is a frozen tide. Every aquifer is an echo of the first ocean, still circling through the body of the world. And as long as water moves, even unseen, the earth will remain alive. Far below the crust, where sunlight has never reached and sound travels as vibration through molten stone, there exists a realm so strange that our language struggles to describe it. It is not ocean in the way we know it, with waves or currents, yet it is water in a different state, locked inside the mantle, compressed beyond recognition. It moves slowly, not as a liquid, but as a memory of one, influencing the planet's shape and temperature from within. For centuries, humanity believed the Earth's interior was dry, a furnace of silicate and metal sealed away from the oceans above. But every discovery of water-bearing minerals tells a different story. Deep within the mantle, minerals like wadzleyite and ringwoodite hold water not as droplets, but as hydroxyl ions, chemically bound into their structure. A single cubic kilometer of such rock can contain more than 1 billion tons of water. Across the vast expanse of the mantle transition zone, between 400 and 700 kilometers deep, that adds up to an unimaginable quantity, perhaps 3 times the water in all Earth as surface oceans combined. This hidden reservoir was first hinted at through seismic waves. When earthquakes send vibrations through the planet, the waves slow down or bend, depending on what they pass through. By measuring these shifts, scientists can infer composition. What they found was startling. Certain regions deep below North America and Asia behaved as though saturated, absorbing energy like damp sponges. Samples of volcanic rock ejected from deep source eruptions later confirmed it. They contained the mineral ringwoodite, flecked with microscopic traces of water. Those inclusions were not contamination from the surface. They were fragments of the mantle's own ocean. At such depths, temperature and pressure transform water into something almost unrecognizable. Between the solid mantle and the molten outer core, hydrogen and oxygen separate and rejoin in exotic configurations. One of these forms is known as superionic water. In this state, oxygen atoms remain fixed in a crystalline lattice, while hydrogen ions flow freely, turning the material into a conductor of electricity. It behaves neither like a solid nor a liquid, but something in between, a phase that may exist in the interiors of giant planets such as Neptune and Uranus. There, entire oceans of superionic water could circulate, generating magnetic fields that twist and shimmer across their atmospheres. If such material exists on Earth, it would occupy the deepest parts of the mantle, near the boundary with the core. It would not be water, as we can imagine touching, but its essence, hydrogen moving freely, carrying charge, allowing the planet's dynamo to function. Without water, the core might cool differently, the magnetic field might falter, and the atmosphere might slowly erode under the solar wind. Thus, even in its most alien form, water protects life at the surface. The discovery of water in the mantle changes how we see Earth itself. It means that the planet is not divided between ocean and land, wet and dry, but continuous, hydrated throughout. The mantle is a slow ocean of stone, and water is the agent that keeps it mobile. When subducted slabs of crust carry water downward, that water lowers the melting point of rock, creating magma. The magma rises, forming volcanoes and renewing the crust. In this way, the mantle's hidden water cycle drives the creation of continents. Without it, the surface might have remained flat and barren. The circulation of water through these depths is unimaginably slow. What we call geological time, millions of years, is the rhythm of this movement. A drop of seawater drawn into the mantle at a subduction zone may not return for hundreds of millions of years, re-emerging in volcanic gases long after continents have shifted. Yet it does return. Even across the span of deep time, water does not rest. Each eruption that releases steam and vapor is a message from this buried ocean. The plumes rising from volcanic vents, the mist that drifts over new lava flows, the sulfurous clouds that hang above calderas, all carry water molecules that were once locked deep within the Earth's structure. When they escape, they join the atmosphere, fall as rain, and eventually seep back down again. It is a dialogue without beginning or end, an exchange between surface and core. In some parts of the world, we can glimpse this cycle at the surface. The geysers of Yellowstone, the fumaroles of Kamchatka, and the steaming plains of Iceland are exhalations of deep water finding its way out. The heat that powers them comes from magma, but the motion, the pulse, belongs to water itself. These places are windows into the hidden hydrology of the planet, rare points where the inner ocean touches the sky. The implications of mantle water extend beyond Earth. If our planet's interior can hold such vast reserves, then other rocky worlds might as well. Mars, though dry on its surface, shows chemical signatures suggesting that water once cycled through its crust in similar ways. Minerals like serpentine and clays, found across its plains, form only in the presence of water at depth. Even now, some scientists suspect that pockets of briny liquid may persist beneath its polar caps, kept warm by geothermal heat. Venus, in contrast, may have lost its internal water early in its history. Without that hidden reservoir to lubricate tectonic movement, its crust became stagnant. Volcanoes still erupt, but the planet no longer recycles its surface as Earth does. Its atmosphere thickened with carbon dioxide, trapping heat until oceans and clouds vanished. The comparison is sobering. One world that kept its inner sea and thrived, another that lost it and burned. On Earth, the deep water acts as a kind of shield. It moderates the temperature of the mantle, maintains the mobility of tectonic plates, and provides the volatile gases that sustain the atmosphere. It is both memory and mechanism, a record of the planet's formation and a driver of its ongoing renewal. Without it, the surface would grow brittle, the climate unstable, the cycle of life incomplete. Yet even this immense reservoir is not uniform. It is patchy, shifting, more like a mosaic than a continuous layer. Beneath some regions, the mantle is dry. Beneath others, saturated. The reasons for this variation lie in the planet's chaotic history: collisions, subductions, plumes of rising heat. Over billions of years, continents have broken and reassembled, dragging water with them. The deep Earth is a collage of ancient oceans, each preserved in stone. The notion that so much water exists in the mantle raises a question of origin. Where did it come from? Was it delivered by comets and asteroids, as some theories suggest, or was it bound within the minerals of the early planet from the start? Evidence increasingly supports the latter. Studies of meteorites, the building blocks of Earth, show that many contain hydrated minerals similar to those in the mantle. Water, it seems, was present from the beginning, locked into rock as the planet formed. The ocean was never an addition. It was an emergence, a revelation of what was already there. To think of Earth in this way is to reverse the familiar image. The sea did not cover a dry world. Rather, the world exhaled the sea. Volcanic steam condensed into rain, rain gathered into basins, and the cycle began. The mantle's hidden ocean was the source of the surface one, and remains its reservoir still. As science maps these deep processes, it encounters limits of perception. We cannot directly sample the mantle's water. We can only infer its presence through the behavior of minerals and waves. It is a form of knowledge built on listening to the tremors of the planet, to the whispers of crystals, to the signals of isotopes in volcanic gas. This listening mirrors the work of contemplation itself, to sense what moves beneath silence, to recognize meaning in vibration. In that sense, geology and meditation share a common language. Both are arts of patience. Both reveal that change does not always require motion. Beneath apparent stillness, transformation is constant. The mountain that seems eternal is, in truth, flowing, imperceptibly, but flowing nonetheless. The mantle, with its slow churn of hydrated rock, teaches this lesson perfectly. It moves so slowly that to human eyes it seems still, yet it is the reason continents drift and volcanoes burn. The existence of water in such places is an act of paradox. Heat creating the condition for liquidity, pressure turning vapor into solid, stone carrying the essence of fluid. It challenges our categories. What is water when it no longer flows, but still connects? When it shapes planets without ever being seen? Perhaps it is less a substance than a relationship, a way in which the universe keeps matter in conversation with itself. The relationship between water and stone is one of perpetual negotiation. Each shapes the other, each defines the other's boundaries, yet neither ever wins. Inside the mantle, this dialogue has been ongoing for more than 4 billion years. It is water that softens rock enough for continents to drift, and rock that holds water captive long enough for oceans to exist at all. The balance between them is delicate, but it has endured across ages of fire and ice. When scientists model the movement of the mantle, they find that even the slightest change in water content alters its behavior. A few parts per thousand can determine whether rock flows easily or locks in place. In this way, a small presence exerts immense power. The mantle's slow circulation, called convection, is driven partly by this subtle lubrication. Without it, heat from the planet's core would accumulate, crustal plates would cease to move, and volcanic outgassing would dwindle. The Earth would grow silent. With it, the crust renews itself continuously, mountains rise, and the atmosphere stays alive. Water is the hidden engineer of the world's architecture. When magma ascends toward the surface, the water dissolved within it lowers its density and viscosity, helping it rise. As the magma cools, that water separates and escapes as steam, driving eruptions that reshape landscapes. The same process feeds hydrothermal vents at the ocean floor, which, in turn, sustain ecosystems of extraordinary complexity. The deep Earth's water emerges as life's benefactor again and again. At subduction zones, the cycle reverses. Oceanic crust, saturated with seawater, dives beneath continental plates and carries its cargo of moisture into the mantle. As it sinks, the water is squeezed from the rock, causing partial melting above. The molten material forms volcanic arcs that line the world's tectonic boundaries: the Andes, the Cascades, the islands of Japan and Indonesia. Every plume of volcanic steam that rises from these regions is a relic of ancient rain, returning to the sky after millions of years underground. In a single volcanic eruption, thousands of tons of water can be released into the atmosphere. Much of the planet's current ocean volume may have passed through this cycle multiple times, distilled by fire and stone. The idea that the sea we know is recycled, that every wave carries atoms that have visited the mantle and come back, lends the familiar horizon an almost sacred continuity. We stand before it, and it stands before time. Deep drilling projects have sought to reach the boundary where crust becomes mantle, the so-called MOHO discontinuity, but none have yet succeeded. The heat and pressure are too great, the technology not yet equal to the task. What we know comes instead from fragments brought up by volcanoes, or from rare meteorites that mimic the planet's interior composition. In laboratories, these samples are pressed and heated to recreate mantle conditions. The results confirm that water changes everything. It reduces melting points, increases conductivity, alters mineral phases. It is not merely present in the deep earth. It defines the deep earth. If one could witness the mantle's interior with perfect vision, it might look like a glowing tapestry of red and gold, moving imperceptibly. Here and there, zones of hydration shimmer faintly, where water within minerals creates pockets of melt. These pockets rise and coalesce, giving birth to magma plumes that feed volcanoes. The movement is slow but unstoppable. Even when the surface sleeps, the interior dreams of motion. At the upper boundary of the mantle, where it meets the crust, groundwater from above sometimes mixes with ascending fluids from below. In regions such as Iceland or Kamchatka, this meeting creates geysers, hot springs, and fumaroles. Each of these is a conversation between surface and depth, a point where the hidden ocean breathes outward. The steam that rises carries the scent of minerals, sulfur, iron, silica, reminders of the planet's inner chemistry. To stand beside a geyser and feel its heat is to stand within that dialogue, to witness a fraction of a cycle that spans the globe. The presence of water in the mantle also shapes the planet's magnetic field. As hydrogen ions move within superionic phases or in partially molten regions, they conduct electricity, influencing the currents in the outer core. These currents generate the geomagnetic shield that deflects solar wind, preserving the atmosphere from erosion. In this way, the water buried hundreds of kilometers below us guards the clouds above us. A chain of dependence runs from the deepest depths to the edge of space. It is remarkable to consider that hydrogen, the lightest element, exerts such power when bound within rock. Under immense pressure, it ceases to behave as gas, and instead becomes a ghostly current, diffusing through minerals and altering their behavior. When enough hydrogen accumulates, it may even separate into metallic form, a state predicted for the cores of giant planets. The same element that flickers in stars also pulses beneath our feet, linking the furnace of the sun to the quiet depths of Earth. Beyond its physical roles, the deep water cycle carries philosophical weight. It suggests that creation and destruction are inseparable. Every volcano that destroys a landscape also releases the water that will create new rivers. Every subduction that drags an ocean downward ensures another will rise elsewhere. The planet renews itself through this endless exchange, a rhythm of taking and giving that mirrors the breath of living things. In human terms, we might call this balance mercy. The earth does not hoard, it circulates. It keeps no part of itself separate for long. Even continents, which seem fixed, drift slowly, sinking and rising with the motion of the mantle below. The hidden water binds them to that movement. To understand this is to see that stability is not the absence of motion, but its equilibrium. Water teaches this everywhere it goes. The calm of a lake exists because countless molecules are vibrating in harmony. The stillness of a mountain exists because its minerals are locked in tension, each balancing the forces of those around it. So it is with the mantle ocean, the most massive stillness of all, born from ceaseless motion. Sometimes nature offers glimpses of that slow power. In Hawaii, when lava meets the Pacific, explosions of steam rise into the sky. Each cloud is a reunion, water and fire meeting again after their long separation. The hiss of the steam, the crackle of cooling rock, the drift of vapor into wind, these are the audible notes of the earth as internal song. It is a reminder that even destruction is a kind of correspondence, a message sent from depth to surface. If the mantle holds 3 oceans worth of water, then our understanding of sea level is temporary at best. The true measure of the ocean includes everything, liquid, vapor, and bound moisture within stone. Our maps of blue and green show only the visible portion of a much greater body. In truth, the Earth is a single ocean planet, layered rather than separated. The distinction between inner and outer dissolves under this view. The clouds above and the magma below are not opposites, but continuations. The same water that drifts as vapor in the sky may someday sleep as ions in a crystal lattice 1,000 kilometers deep. Time alone separates their states. The cycle is so vast that our lives, our histories, are mere flickers within it. Yet even knowing this, the human mind finds meaning in smallness. A glass of water, held to the light, contains the whole story in miniature: reflection, refraction, transparency, memory. Its molecules might have been part of ancient rain, of volcanic steam, of a mantle mineral's hidden hydration. They might have passed through the blood of animals or the sap of trees. To drink is to participate in the continuity of matter, to accept the inheritance of all who came before. Every mouthful of water is communion with the deep. It carries not only minerals and isotopes, but the subtle vibration of the planet's history. Within each molecule, bonds stretch and relax billions of times per second, resonating with the same frequencies that shape tides and tectonics. We do not feel it, yet our bodies respond, aligning heartbeat and breath to the rhythm of the world. Perhaps this is why water so easily induces calm. It reminds the body of its origin. When rain falls, when rivers flow, when geysers burst, each act is an expression of the same interior reservoir. The mantle ocean is the wellspring from which all surface motion arises. It is the memory that keeps the earth soft and alive. And though we cannot see it, we live by its grace, walking on a crust that floats atop its invisible waves. Beneath the immense pressure of the lower mantle, where the weight of the planet compresses matter to densities beyond imagination, water, persists in forms more ancient than language. It is not liquid, nor vapor, nor ice, but something in between, a whisper of mobility trapped inside stone. And yet, its presence changes everything it touches. Even when bound, water softens the mantle's rigidity, allowing it to convect, to flow, to breathe heat outward in pulses that shape continents. When earthquakes ripple across the planet, they are the surface tremors of this deeper breathing. Each seismic wave travels faster or slower, depending on how much water resides in the rock it passes through. In this way, the Earth speaks its composition through vibration. Scientists who study these tremors can, in a sense, hear the hidden ocean, not as sound, but as the music of density and resonance. The data reveals that beneath many subduction zones, hydrated slabs extend deep into the mantle transition zone, carrying water farther down than once believed possible. There, under unimaginable pressure, minerals transform, releasing bursts of energy that may even trigger deep focus earthquakes, the shivers of a planet remembering its own currents. In the mantle's heat, water does more than soften rock. It alters chemistry. It allows elements to move, to combine, to separate. Without water, the silicates that compose the mantle would remain locked in their crystalline order, immobile. With water, that order loosens. Atoms migrate, and new minerals form. This process, called metasomatism, is one of Earth's quietest miracles, the slow rewriting of stone by moisture. Over millions of years, it creates the diversity of rocks we see at the surface: basalts, granites, schists, and marbles. Each began as something else, transformed by water's invisible hand. To understand the magnitude of this transformation, consider that every mountain once existed at the bottom of an ocean, and every ocean has held mountains within it. The mantle's water allows this continual exchange, land becoming sea, sea becoming land. The Himalayas, highest peaks on Earth, contain fossils of marine creatures once swimming in the Tethys Sea. They are proof that even the most immovable stone was once dissolved in water's patience. The deep reservoirs, though hidden, are the architects of this endless rising and sinking, the unseen engineers of change. As scientists refine their models of the mantle's hydration, they uncover patterns that mirror those found in biology. Just as blood carries oxygen through living tissue, so does water carry energy and minerals through the Earth's interior. The mantle, like a vast circulatory system, moves nutrients that nourish the crust above. When volcanoes erupt, they bring to the surface not only molten rock, but also trace elements: iron, phosphorus, carbonates that later feed the biosphere. The ocean, enriched by these minerals, supports plankton, which in turn release oxygen to the air. And so the cycle closes again: mantle to volcano, volcano to ocean, ocean to life, life to atmosphere. Every breath we take is, in a distant way, a gift from the water buried deep below. Even deeper still, near the boundary of the core, water encounters iron. At pressures millions of times greater than at the surface, hydrogen from dissociated water atoms diffuses into the molten metal, while oxygen reacts with silicates to form new compounds. These reactions influence the convection currents that generate the magnetic field. It is a delicate interplay, water feeding the dynamo that shelters life from solar radiation. Without it, the magnetosphere might fade, the atmosphere might erode, and the planet would stand exposed. The deep ocean of hydrogen and iron is, in that sense, the quiet guardian of everything that breathes. The study of superionic water has revealed how strange this inner world may be. In laboratory simulations, scientists subject water to pressures exceeding 1 million atmospheres and temperatures hotter than lava. Under these conditions, the oxygen atoms freeze into a crystalline grid, while hydrogen ions flow like liquid through the lattice, conducting electricity 1,000 times more efficiently than seawater. This phase, both solid and fluid, may exist at the boundary between the mantle and the core. a sheath of shimmering conductivity enveloping the heart of the world. If we could see it, it might resemble a glowing storm cloud, motionless yet seething with energy. In giant planets like Neptune and Uranus, such supersonic water may form entire mantles thousands of kilometers thick. The peculiar tilt and fluctuation of their magnetic fields suggest that these deep, electrically active oceans are constantly shifting, generating fields that twist and wobble like auroras trapped within. To know that such alien oceans exist, not of blue waves, but of glowing ions, is to glimpse water's infinite versatility. It can be ice or vapor, liquid or crystal, conductor or insulator, depending only on pressure and time. And because of this adaptability, water is cosmic. It is found not just on planets, but in the cold interstellar medium, frozen onto dust grains drifting between stars. It condenses in comets, hides in meteorites, and clings to the shadows of asteroids. The same molecule that glistens in a dewdrop on a leaf also coats the surfaces of moons beyond Saturn. Across billions of miles, water repeats its pattern, binding, melting, reforming, a universal solvent connecting every world that has ever been. When one contemplates this continuity, the notion of separation dissolves. The water within Earth's mantle may share an origin with that inside distant comets. The hydrogen in our oceans might have formed in the core of an early star. The oxygen, forged in another long since gone supernova, drifted through space until gravity bound it to this planet. Together they became liquid, then vapor, then stone-bound memory, cycling endlessly. Every molecule of water carries the record of cosmic ancestry, a lineage unbroken since the birth of the galaxy. In the vast underground reservoirs of Earth, that cosmic memory remains active. The mantle's hidden ocean is a bridge between creation and renewal, a reminder that nothing vanishes, it only changes form. When we speak of the hydrological cycle, we often picture clouds and rain, rivers and seas. But the true cycle extends far beyond sight. It begins in the mantle, rises to the surface, ascends into the sky, and then returns. It is not a loop, but a spiral, always moving, always deepening. Water's persistence under such extremes also offers clues to where life might exist elsewhere. On distant exoplanets with internal heat, similar deep oceans may provide stability and energy for biological chemistry. Even without sunlight, hydrothermal reactions between water and rock could sustain microbial life, as they do here. The blueprint is universal. Where water endures, complexity follows. And yet, even with all our understanding, mystery remains. The exact amount of water within the Earth is uncertain by orders of magnitude. Some estimates suggest a mantle ocean 3 times larger than all surface seas. Others propose 10 times. We may never know precisely, for to reach it would mean descending into pressure and heat beyond endurance. Perhaps that inaccessibility is part of its meaning, that some aspects of creation are meant only to be felt through reverence, not conquered by reach. When you stand by the sea and feel the wind rising off the waves, you are touching the outer breath of this inner ocean. The moisture in the air, the salt on your skin, the shimmer on the horizon, all are connected to the deep, unseen water that turns within the planet. The surface ocean is the mirror. The mantle is the heart. Together, they complete the Earth's body, pulsing in rhythms measured not in days or seasons, but in eons. To listen for this pulse is to slow down enough to feel the deep time beneath your feet. Each step we take presses against stone that once flowed, once held water, once whispered to the core. Every mountain is part of that whisper, every cloud a reply. The conversation never ends. So we return to stillness, to the recognition that the hidden ocean is not separate from us. The hydrogen that moves within the mantle also moves within our blood. The pressure that shapes stone shapes our bones. The rhythm of tides mirrors the rhythm of the heart. We are, in the most literal sense, extensions of that ancient conversation between water and fire. The mantle's reservoirs will continue their work long after the surface changes. Continents will drift, seas will rise and fall, but the deep ocean beneath everything will endure, patient and unbroken. It will carry within it the memory of all that has lived and all that will come. In its darkness, the blueprint of life will remain, waiting for light to find it again. And yet, even now, there is more to say, because to understand the ocean within the earth is to understand the one within ourselves, and how they are, in truth, the same. Imagine for a moment the water molecule, 2 atoms of hydrogen, 1 of oxygen, joined by the simplest of bonds. That bond, so fragile it can break with light, is also the most abundant chemical relationship in the universe. Every vibration of that bond, every stretch and release, creates a resonance that travels outward through the cosmos. This is the quiet hum beneath existence, the frequency of water remembering what it once was. When you listen to the deep sea, to the murmur of waves against cliffs, you are hearing echoes of that same vibration, magnified through a billion transformations. The sound of water is the sound of molecules recalling their history, from nebula to ocean, from magma to rain. The sea is a vast instrument, and the Earth's mantle is its deepest string. Some scientists have speculated that the vibration of the planet itself, the microseisms that hum continuously, even in the absence of wind or storm, may be partly caused by the movement of water through the crust and mantle. If so, then the planet is never silent. It is always singing softly. Its song carried not through air, but through stone. That song tells us something profound, that water is not passive. It is active memory. Each time it freezes or melts, evaporates or condenses, it remembers its last state and carries that pattern forward. Crystals of ice retain traces of the atmosphere in which they formed. Raindrops inherit the salts of their clouds. Mantle minerals preserve the isotopic fingerprints of ancient oceans. Water does not forget. If we follow that thought further, we might see the ocean not as matter, but as motion, a continuity that never began and will never end. It was already ancient before the first sun ignited. When the solar system formed from gas and dust, hydrogen atoms, the simplest of all, paired with oxygen to create the first molecules capable of persistence. They condensed in the cold reaches of space, froze, thawed, and froze again as comets. When those comets struck the forming Earth, they may have added to the water already bound within minerals. And so, before continents or air or light, there was water. Deep in the mantle today, that first water still lingers, older than any ocean, untouched since the planet's birth. It has circulated countless times through stone, magma, and steam, yet its atoms are the same. It is the original element of connection, the archive of creation written in chemical language. There is a strange comfort in this, that the water we drink, the water within our veins, shares its lineage with that buried ocean. The distance between us and the mantle, between the surface and the core, is not separation, but depth. We are layered expressions of the same material, animated by the same cycles. Even our emotions mirror this structure. The word flow describes both water's motion and the state of human consciousness when we move without resistance. Depth describes both the sea and the mind. The metaphors we use are not accidents. They arise because our bodies remember what the earth knows. We are mostly water, and that water once moved through rivers of stone. Perhaps it carries with it the memory of pressure, of darkness, of patience. When we feel drawn to the sound of waves, it may be because something within us recognizes its origin. The pulse of tides matches the rhythm of our heartbeat at rest, one cycle every second or so. The nervous system, attuned to vibration, resonates with that pattern. The ocean calms us because it is the original tempo of life, and that rhythm is universal. If we could stand on Europa or Enceladus, Listening beneath their icy crusts, we would likely hear a similar beat, the slow movement of water responding to gravity, heat, and time. The same physics that governs our mantle governs theirs. The same molecule that carved Earth's canyons drifts through their hidden seas. We are surrounded by reflections of ourselves across the cosmos. Back on Earth, water's journey continues upward as well as downward. Through volcanoes, it escapes as steam. Through plants, as transpiration. Through breath, as vapor. Every exhalation of a living creature is a return of water to the sky. The atmosphere, delicate as a membrane, receives it and folds it into clouds. From there, it falls again as rain, beginning the cycle anew. The motion of life and the motion of geology are the same motion, merely seen at different scales. It is this unity that makes water sacred in every culture. Long before science revealed its molecular secrets, people understood its holiness. The ancients saw rivers as veins of the earth, springs as portals to the divine, rain as the language of the heavens. In their myths, the world always begins with water, an endless sea from which land rises like breath from sleep. They were right in more ways than they could have known. Modern science, in its own way, has circled back to that truth. We now know that the entire cosmos is threaded with water, not oceans, but the ingredients of them, scattered like seeds through the void. When telescopes analyze the light from distant nebulae, they find the spectral signature of water vapor. In the darkness between stars, frozen molecules cling to dust, waiting for heat to wake them. The story of life begins not with light, but with the chemistry of water waiting to move. This realization reshapes how we see ourselves. The ocean within the mantle, the ocean beneath the ice of Europa, the ocean of vapor in a nebula, all are versions of one eternal gesture. Hydrogen meeting oxygen, energy meeting potential, silence meeting motion. Water is the universe's first collaboration, the bridge between chaos and form. And because of that, water is patient beyond imagination. It endures cycles of freezing and thawing, burial and release, evaporation and condensation across billions of years. It has no allegiance to state or place. It flows where gravity calls, seeps where pressure opens a path, and waits when it must. Even when locked in crystal or bound in rock, it remains ready. This patience is not weakness. It is wisdom. The universe expands and collapses, stars are born and die, yet water persists. It does not resist transformation, and so it survives everything. The mantle ocean, pressed beneath unimaginable weight, is the ultimate symbol of that endurance, quiet, unseen, and indispensable. If humanity were to vanish tomorrow, if cities crumbled and rivers dried, the hidden water would continue its slow conversation with stone. It would rise and fall, dissolve and reform, unconcerned with memory or loss. And in some distant epoch, when new life emerges, it will rise again as cloud, as rain, as sea. Perhaps then the most profound truth of the hidden ocean is this: permanence is an illusion. Only flow is real. The water that forms your body today may tomorrow belong to a mountain, a cloud, a grain of sand, or the mantle itself. And yet, through all those changes, it remains what it has always been: the connector, the listener, the keeper of continuity. So when you close your eyes and listen to the quiet, try to imagine the sound beneath the silence, the hum of water moving through rock, the whisper of hydrogen within stone. That is the earth's deepest voice. It speaks not in words, but in movement. It says, "I'm still here." And we, made of that same motion, reply without sound. So are we. The ocean within the earth continues to move, even in this moment. Its pace is beyond perception, yet its influence is everywhere. The mantle breathes through volcanoes and geysers, its vapors carried into the air, its minerals returned as dust on the wind. Every raindrop that falls carries a trace of that ancient exhalation, a whisper from a depth no sunlight has ever touched. When we breathe, we are participating in that exchange. The oxygen in our lungs was freed from stone by water. The carbon we exhale will eventually return to the mantle through the slow sedimentation of the sea. Life is simply the temporary arrangement of those two movements, breathing in what the ocean once released and breathing out what it will one day reclaim. To think of it this way is to sense the subtle humility of existence. Nothing we call ours has not been elsewhere before. The water in our veins may have once lain beneath a mountain. The salts on our tongue may have once drifted through volcanic mist. The atoms of our blood are the same that shimmer in deep magma or freeze in polar ice. When we look at the sea, we are looking at the reflection of our own composition. In the stillness of night, if one could listen beyond the surface noises of wind and tide, one might hear the faint murmuring of the deep interior. Not as sound, but as vibration. Seismometers record this constant pulse, a low-frequency hum produced by waves of energy traveling through the planet. It is the sound of the mantle's heartbeat, too slow for the ear, but ever present. The earth hums in its sleep, and water is what gives that hum its tone. Every earthquake, every eruption, is a reminder of that motion, but it is the steady whisper that defines the planet. It is what keeps the magnetic field alive, what maintains the delicate balance of temperature between core and crust. Without the movement of water in the mantle, the earth would harden, its magnetic shield would fade, and its surface would fall silent. Life, if it persisted at all, would cling only to shadows of what once was. The hidden ocean is a kind of mercy. It allows the planet to bend instead of break, to yield under pressure instead of shattering. This same principle applies everywhere water exists. In our own bodies, water grants softness, flexibility, and response. A dry cell is a dead one. A dry world is a silent one. Water gives the capacity to change shape without losing identity. Even our emotions mirror this structure. The word flow describes both water's motion and the state of human consciousness when we move without resistance. Depth describes both the sea and the mind. The metaphors we use are not accidents. They arise because our bodies remember what the earth knows. We are mostly water, and that water once moved through rivers of stone. Perhaps it carries with it the memory of pressure, of darkness, of patience. When we feel drawn to the sound of waves, it may be because something within us recognizes its origin. The pulse of tides matches the rhythm of our heartbeat at rest, one cycle every second or so. The nervous system, attuned to vibration, resonates with that pattern. The ocean calms us because it is the original tempo of life, and that rhythm is universal. If we could stand on Europa or Enceladus, listening beneath their icy crusts, we would likely hear a similar beat, the slow movement of water responding to gravity, heat, and time. The same physics that governs our mantle governs theirs. The same molecule that carved Earth's canyons drifts through their hidden seas. We are surrounded by reflections of ourselves across the cosmos. Back on Earth, water's journey continues upward as well as downward. Through volcanoes, it escapes as steam. Through plants, as transpiration. Through breath, as vapor. Every exhalation of a living creature is a return of water to the sky. The atmosphere, delicate as a membrane, receives it and folds it into clouds. From there, it falls again as rain, beginning the cycle anew. The motion of life and the motion of geology are the same motion, merely seen at different scales. It is this unity that makes water sacred in every culture. Long before science revealed its molecular secrets, people understood its holiness. The ancients saw rivers as veins of the earth, springs as portals to the divine, rain as the language of the heavens. In their myths, the world always begins with water, an endless sea from which land rises like breath from sleep. They were right in more ways than they could have known. Modern science, in its own way, has circled back to that truth. We now know that the entire cosmos is threaded with water, not oceans, but the ingredients of them, scattered like seeds through the void. When telescopes analyze the light from distant nebulae, they find the spectral signature of water vapor. In the darkness between stars, frozen molecules cling to dust, waiting for heat to wake them. The story of life begins not with light, but with the chemistry of water waiting to move. This realization reshapes how we see ourselves. The ocean within the mantle, the ocean beneath the ice of Europa, the ocean of vapor in a nebula, all are versions of one eternal gesture. Hydrogen meeting oxygen, energy meeting potential, silence meeting motion. Water is the universe's first collaboration, the bridge between chaos and form. And because of that, water is patient beyond imagination. It endures cycles of freezing and thawing, burial and release, evaporation and condensation across billions of years. It has no allegiance to state or place. It flows where gravity calls, seeps where pressure opens a path, and waits when it must. Even when locked in crystal or bound in rock, it remains ready. This patience is not weakness. It is wisdom. The universe expands and collapses. Stars are born and die, yet water persists. It does not resist transformation, and so it survives everything. The mantle ocean, pressed beneath unimaginable weight, is the ultimate symbol of that endurance, quiet, unseen, and indispensable. If humanity were to vanish tomorrow, if cities crumbled and rivers dried, the hidden water would continue its slow conversation with stone. It would rise and fall, dissolve and reform, unconcerned with memory or loss. And in some distant epoch, when new life emerges, it will rise again as cloud, as rain, as sea. Perhaps then the most profound truth of the hidden ocean is this: permanence is an illusion. Only flow is real. The water that forms your body today may tomorrow belong to a mountain, a cloud, a grain of sand, or the mantle itself. And yet, through all those changes, it remains what it has always been: the connector, the listener, the keeper of continuity. So when you close your eyes and listen to the quiet, try to imagine the sound beneath the silence, the hum of water moving through rock, the whisper of hydrogen within stone. That is the earth's deepest voice. It speaks not in words, but in movement. It says, "I'm still here." And we, made of that same motion, reply without sound. So are we. The ocean within the earth continues to move, even in this moment. Its pace is beyond perception, yet its influence is everywhere. The mantle breathes through volcanoes and geysers, its vapors carried into the air, its minerals returned as dust on the wind. Every raindrop that falls carries a trace of that ancient exhalation, a whisper from a depth no sunlight has ever touched. When we breathe, we are participating in that exchange. The oxygen in our lungs was freed from stone by water. The carbon we exhale will eventually return to the mantle through the slow sedimentation of the sea. Life is simply the temporary arrangement of those two movements, breathing in what the ocean once released and breathing out what it will one day reclaim. To think of it this way is to sense the subtle humility of existence. Nothing we call ours has not been elsewhere before. The water in our veins may have once lain beneath a mountain. The salts on our tongue may have once drifted through volcanic mist. The atoms of our blood are the same that shimmer in deep magma or freeze in polar ice. When we look at the sea, we are looking at the reflection of our own composition. In the stillness of night, if one could listen beyond the surface noises of wind and tide, one might hear the faint murmuring of the deep interior, not as sound, but as vibration. Seismometers record this constant pulse, a low-frequency hum produced by waves of energy traveling through the planet. It is the sound of the mantle's heartbeat, too slow for the ear, but ever present. The earth hums in its sleep, and water is what gives that hum its tone. Every earthquake, every eruption, is a reminder of that motion, but it is the steady whisper that defines the planet. It is what keeps the magnetic field alive, what maintains the delicate balance of temperature between core and crust. Without the movement of water in the mantle, the Earth would harden, its magnetic shield would fade, and its surface would fall silent. Life, if it persisted at all, would cling only to shadows of what once was. The hidden ocean is a kind of mercy. It allows the planet to bend instead of break, to yield under pressure instead of shattering. This same principle applies everywhere water exists. In our own bodies, water grants softness, flexibility, and response. A dry cell is a dead one. A dry world is a silent one. Water gives the capacity to change shape without losing identity. In this sense, the ocean beneath everything is not only a structure of the planet, but also a metaphor for consciousness itself. Thought moves like water seeking lower ground, finding paths of least resistance, eroding barriers over time. The mind, like the mantle, holds its own hidden circulation, where impressions and memories sink and rise in cycles too deep to map. We may think we are still, but beneath every stillness, there is movement. Even our history mirrors this pattern. Civilizations rise where water gathers and decline when it withdraws. Ancient rivers defined the borders of the first cities, and when those rivers changed course, cultures vanished. Yet the water did not die. It merely found another path. It reminds us that permanence is illusion, and that continuation is the truer form of survival. The deep earth teaches the same lesson. Continents drift, collide, and fracture, yet the underlying flow persists. The Pacific Plate slides beneath the Americas, carrying with it sediments, shells, and ancient seabed. Millions of years later, that material returns as mountains or islands, new landscapes shaped from recycled sea. Every grain of sand, every pebble on a shore is a relic of subduction, a fragment of something that once lay hidden in darkness. In mythology, this eternal return is often symbolized by the serpent devouring its own tail, the Ouroboros. The symbol captures what the deep ocean performs in reality, a cycle without beginning or end. Water descends, transforms, ascends, and begins again. It consumes itself only to renew itself. The planet, like the serpent, survives through this perpetual renewal. When we look at the sea and feel calm, perhaps it is because our nervous system recognizes that pattern of return. The mind, which so often clings to linear time, relaxes in the presence of water's cyclical motion. The waves demonstrate that everything moves forward and back in balance. They whisper that even loss is temporary, that every ebb carries within it the promise of flow. The mantle ocean holds this principle in its quiet depths. For billions of years, it has cycled water, rock, and energy without exhaustion. Its endurance gives rise to everything familiar: mountains, air, even the possibility of memory. Yet it remains humble, invisible, selfless. It exists not to be seen, but to sustain. We rarely thank it, though we depend on it more completely than on any visible sea. The air we breathe, the soil that grows our food, the very stability of the ground beneath us all, are gifts of the ocean we will never touch. Its invisibility is not absence, but generosity. Like the roots of a tree, its hiddenness allows everything else to stand in light. To contemplate this is to feel a slow gratitude rising. The knowledge that beneath the noise of the world, a vast and patient system works endlessly to keep balance. It does not require our belief or attention. It simply flows, keeping the planet soft enough to breathe, old enough to remember, and young enough to begin again. If one could descend through the crust, through layers of shifting mineral, one might eventually reach that boundary where the world begins to glow. There, in the dim orange pressure, moisture moves through stone like veins through flesh. Each molecule is ancient, but alive with motion. It travels between atoms, altering the lattice as it passes, leaving a trace of its presence. In that glow, water and rock are not separate substances, but two expressions of the same process. One yielding, one shaping, both enduring. To remain in that imagined descent is to feel distance dissolve. The deeper one goes, the less the world divides into layers. Heat and pressure erase boundaries until everything becomes motion. There is no more crust, no more core, only the slow migration of energy through matter. Water, in its ghostly forms, threads it all together. If you could drift within that mantle glow, you might see tiny flashes where minerals shift phase, solid turning liquid, liquid becoming crystal, a shimmer of rearrangement, too slow for eyes, but constant as breathing. Each flicker is a pulse of change, and each carries water's signature. It is the quiet art of the planet maintaining itself. Every pulse, in time, makes its way upward. It might take 1,000,000 years, but it will arrive. One day that buried moisture will surface as volcanic steam, rise through cloud, fall as rain, carve a valley, feed a river, nourish a seed, become the sap of a tree, the blood of an animal, the tear of a person watching the sea. Then, drawn again by gravity and erosion, it will return underground, carrying memories of light into darkness once more. This is how the earth dreams slowly, through the movement of water. It dreams of balance, of renewal, of the ceaseless conversation between fire and fluid. And we, standing on its skin, are the fleeting consciousness of that dream. There are moments when the connection becomes almost audible. In the silence before dawn, when the air is heavy with mist, the world feels as though it is listening. Beneath your feet, water shifts inside the soil. Beneath that soil, aquifers adjust their pressure. Beneath them, the mantle swells ever so slightly, expanding and contracting as heat moves outward. It is all one motion, slow enough to hold the stars steady, subtle enough to let grass grow undisturbed. To know this is to find peace in scale. Our lives, so brief against the span of the mantle cycle, are not separate from it. We are events within its continuity, temporary shapes of its persistence. Just as the ocean waves are the surface expression of deeper tides, our stories are surface expressions of this deeper flow. In the same way that the mantle carries water, we carry understanding. We move it from generation to generation, sometimes changing its form, sometimes letting it rest. Knowledge, like water, seeps through the cracks of time, saturating what it touches, softening what was once rigid. It erodes ignorance the way rivers erode stone, not through force, but through patience. Perhaps this is why so many creation myths speak of life emerging from water. It is not only a symbol, it is memory. The body remembers that first environment, the warm saline of the womb, itself an echo of the primordial sea. Every heartbeat is a tide, every breath a wave. Even thought moves rhythmically, swelling and receding in patterns that mirror the pulse of the ocean. When ancient mystics said that the world is alive, they were describing what science now measures. The circulation of the mantle, the migration of groundwater, the slow exhalations of volcanoes, these are vital signs. They are proof of metabolism on a planetary scale. The Earth is not a rock in space, it is a body, and water is its blood. Within this perspective, the boundaries between physics, biology, and philosophy dissolve. A droplet of rain and a crystal of superionic ice share the same essence, only expressed in different conditions. A human tear and a plume on Enceladus are both parts of one great continuity, separated by distance, but united by structure. The cosmos is a single conversation about how matter learns to move, and water is its vocabulary. When we finally learn to listen fully to seismic hums, to spectral lines of distant planets, to the pulse in our wrists, we may recognize that the song is the same everywhere. It says softly, flow continues. And perhaps that is all creation ever needed to say. As we ascend again from the depths of imagination, back toward the surface, the understanding remains. The ocean beneath everything is not metaphor. It is mechanism, memory, and mercy combined. It holds the planet in balance, just as emotion holds meaning in the human heart. Invisible, essential, infinite in patience. Some night, long from now, when continents have rearranged and new oceans have formed, that hidden water will still be moving. It will still be carrying the heat of the core upward, the weight of mountains downward. It will still be writing the story of existence in cycles of condensation and return. And somewhere in that future, another species may stand by another sea, wondering where the sound of waves begins. In the beginning, there was only silence and motion, a whisper of light folding into space, a ripple through the dark. Out of that ripple came the first ocean, not of water, but of possibility. Hydrogen met oxygen in a delicate union, and the universe began to remember what it meant to flow. The same chemistry that would one day fill seas on distant worlds was already stirring in the heart of stars. Everywhere the cosmos turned, water followed. It formed in the cooling breath of nebulae, in the frozen tails of comets, in the vapor rising from young planets that glowed like molten pearls. Even before Earth was born, the universe was already wet with memory. The Milky Way itself shimmered like a tide, and in that tide drifted the seeds of oceans yet to come. When Earth formed, it was fire, molten and furious. Yet beneath the storms of stone and gas, something gentle waited. Comets arrived carrying frozen oceans within them, fragments of the cosmos crashing down to fill the cracks of a cooling world. Steam rose, condensed, and fell as rain for centuries without end. And when it settled, the first oceans stretched out beneath the newborn sun, reflecting light back into the sky that had given them life. Those oceans learned to breathe. Lightning struck their surfaces, and chemistry began to stir. Amino acids, proteins, fragile membranes, all learning the art of persistence. The sea became a cradle where matter dreamed itself into meaning. From that water came the first cell, the first hunger, the first pulse. Evolution was not invention, but memory, the universe recalling what it already knew, that to live is to flow. The story spread outward again. As life filled the seas, water began to shape everything, carving rivers through continents, sculpting mountains into dust, carrying whispers of salt and time into every crevice of the planet. Even when creatures left the ocean, they took it with them. Every cell retained the chemistry of the tide. Every heartbeat became the echo of waves. The ocean moved inward, becoming blood, breath, and thought. And yet, Earth was never alone in this communion. Across the void, other oceans slept beneath ice and shadow. On Europa, a moon of Jupiter, a vast sea churns beneath a crust of frozen light. Geysers pierce its surface, releasing plumes of vapor into space, like breath escaping a dream. On Enceladus, Saturn's smallest moon, fountains of water rise hundreds of kilometers into the void, glittering like diamonds against the darkness. Even on Mars, dry and red, there are traces of rivers that once sang across its valleys. The cosmos, it seems, is filled with memory of flow. Oceans without shorelines, waves without wind, waiting for light to find them. To think of water is to think of time. It holds no shape, yet remembers every shape it touches. It falls as rain, freezes as glacier, burns as steam, and returns again to its source. It is patient, infinite, impossible to destroy. When we look at the sea, we are looking at the oldest part of ourselves, the mirror in which both planet and soul first saw their reflection. We are born from that reflection. Before we take our first breath, we float in a private ocean, our blood salinated like ancient seas. When we emerge, we do not leave the water, we merely learn to carry it within. 70% of us is ocean still, flowing through capillaries, gathering behind eyes, turning thought into tide. Every tear, every drop of sweat, every exhaled breath is a message from that ancient memory. The ocean speaks through us in whispers of salt. To drink water is to take in the universe's memory, to swallow the history of stars and glaciers, clouds and rivers, comets and moons. Each molecule has traveled across billions of years, through countless forms, across worlds. It is a traveler older than life itself. The water you hold in your hand may have once cooled the surface of Mars, frozen in a crater, or drifted as vapor through Saturn's rings. Every sip is a communion with everything that has ever lived or dreamed. And perhaps that is the greatest truth water offers, that there is no separation. Every droplet connects to another through the invisible threads of evaporation and rain. The ocean within you once belonged to mountains, whales, clouds, and comets. When you breathe out, a little of your sea joins the air, travels across continents, and returns as rain to someone else's skin. The planet itself is one vast circulation, a single ocean changing shape, never ending, never still. In its movement lies wisdom. Water teaches the power of yielding, how to carve stone not through force, but through persistence, how to reflect light without holding it. It cleanses not by erasing, but by carrying. It does not resist gravity. It dances with it, and when it meets fire, it does not perish. It transforms. To live like water is to understand that strength lies not in solidity, but in motion. Even in the farthest corners of the solar system, water hums the same song. In the icy crust of Pluto, in the mist of Titan's methane lakes, in the thin frost that clings to Mercury's shadowed craters, it waits, not dead, not silent, only patient. The cosmos does not see oceans as we do. It sees continuity. It knows that wherever water flows, life is possible. And wherever life arises, it dreams again of the ocean. When the universe looks inward through us, perhaps it recognizes itself. Our blood glows with the same elements as stars. Our fluids obey the same laws as comets. The pulse in our veins and the orbit of planets are variations of one rhythm. To listen to the heart is to hear the turning of galaxies in miniature. The water inside us does not end at the skin. It continues outward, dissolving boundaries until everything becomes one slow, eternal tide. So when you stand at the edge of the sea and feel the wind move through your breath, remember this: the ocean is not before you, it is within you. You are not looking at water, you are looking at the reflection of your own beginning. Every wave that breaks is a heartbeat. Every shimmer of light across its surface is thought returning home. And when it withdraws, when it disappears into the horizon, it is not gone. It is simply flowing elsewhere, carrying your memory forward into the endless rhythm of creation. The ocean beneath everything is not just water. It is time, it is memory. It is the universe dreaming itself awake through the quiet motion of flow. The return inward begins gently. After traveling across worlds and through the frozen seas of moons, we come back to where the same story continues, beneath skin instead of stone. The ocean never left us. It moves inside ourselves, whispering with the same rhythm that drives tides. We are mostly water, about 70%, a number that changes with age, diet, sleep, and breath, yet always remains near that sacred ratio of sea to substance. If one could listen closely enough, beneath the sounds of the heart and lungs, one might hear it moving, blood coursing, lymph drifting, the soft tide within. In the earliest weeks of life, before a human has a face or fingers, it floats in a sac of fluid whose salinity matches that of the ancient ocean. Evolution remembers where it began. Every embryo retraces the planet's history, from single cell to organism, from water to air. When birth comes, it is like surf breaking a sudden transition from liquid to atmosphere, from swimming to breathing. Water within us is not passive. It is alive, an active participant in thought, sensation, and repair. Inside every cell, hydrogen bonds form and break faster than any signal the nerves can send, conducting information through motion. Proteins fold in its presence, membranes flex, DNA unwinds and rewinds along its liquid threads. The chemistry of life is not performed in water, but through water. It is not a stage, it is the dance itself. Scientists once called water a solvent, as though it merely hosted the actors of biology. But water is the sculptor of those actors, determining how molecules meet, how energy flows, how the architecture of life takes shape. Every heartbeat, every breath, every thought depends on that subtle asymmetry of hydrogen and oxygen, a quiet polarity that allows the universe to speak through fluid motion. The brain, that delicate constellation of impulses, floats in its own small ocean cerebrospinal fluid that cushions, nourishes, and cleanses. It circulates through the ventricles several times each day, washing away the byproducts of thought. During sleep, the tide within the skull rises, as if the mind itself were being bathed by moonlight. Memory, too, bears the signature of water. Every electric pulse that encodes experience travels through fluid, ions moving like waves. Thought, in its physical form, is the choreography of water, guided by pattern. We remember because our inner sea has learned to flow in familiar shapes and to revisit them. The heart follows the same rhythm. With each contraction, it pushes waves through the body in pulses that mirror the sea. Arteries expand and contract, pressure traveling like surf. The pulse we feel at the wrist is the echo of the planet's oldest rhythm. The salinity of blood mirrors that of seawater from the Cambrian age, carrying traces of our ancient home. We are creatures of the tide, carrying within us the chemistry of trilobites and coral, of storms and glaciers. Each drop of sweat, each tear, each breath replays that ancient song. The salt that dries on our skin is the same that drifts through waves. The tears we shed in grief or joy carry the same minerals that shaped reefs and shells. When we cry, it is as if the sea itself acknowledges the depth of feeling, spilling a little of its memory through us. Water is more than substance. It is response. Sound and vibration shape it, forming patterns when exposed to tone. And we, being mostly liquid, resonate the same way. A calm voice slows the pulse. A song raises gooseflesh. Thunder awakens adrenaline. The inner ocean answers to every note. Breath itself is its tide inhale and exhale, ebb and flow. Meditation is nothing more than listening to that movement. Every living thing performs its own version of this tidal dance. Trees draw water from roots to leaves, releasing it into clouds. Whales rise through miles of water to breathe. Insects in deserts harvest droplets from fog. Even deep underground, bacteria depend on thin films of moisture hidden within stone. Everywhere water goes, continuity follows. Within the human body, it connects systems that would otherwise stand apart. Muscles slide across layers of interstitial fluid. Joints glide on synovial water, renewed by movement. Even bone, seemingly solid, contains tiny canals filled with liquid, transmitting nutrients and vibration. The skeleton, like coral, is porous and alive. This inner ocean keeps us in balance. It regulates temperature, absorbs shock, distributes energy, and maintains equilibrium through gradients osmotic, electrical, gravitational that echo the forces shaping Earth's seas. Whether in a cell or in an ocean, the same principles apply. Salt seeks balance, heat rises, currents form in response to difference. When we drink, we rejoin that pattern consciously. A sip of water is more than hydration. It is communion. The cool descent into the body, the merging with blood, the diffusion into cells, each is a small act of remembrance. The body recognizes itself in the taste. When illness comes, we learn this truth again. Dehydration clouds thought, dries speech, and hardens emotion. Words become difficult when the inner sea recedes. Healing is simply the return of flow, the restoration of movement. The mind clears as the storm passes. The body calms as tide returns. This is why so many spiritual traditions use water as symbol and sacrament. Cleansing, baptism, ablution, all are acts of remembrance. To immerse is to dissolve the boundary between self and world. Renewal begins with surrender to flow. At the molecular level, water behaves like consciousness never still, always forming and dissolving temporary shapes. It is freedom balanced by cohesion, order emerging from motion. Within every cell, miniature weather systems swirl. Molecules condense, disperse, and reform endlessly. Life's precision depends upon that chaos, that capacity to move freely and yet maintain coherence. We often say the body is mostly water, but perhaps it is truer to say that water is mostly body. It learns our rhythms, becomes us for a while, and departs through breath, sweat, evaporation only to return as rain or mist or dew. What leaves us today may one day fall on another's skin. Our individuality is temporary, our liquidity eternal. If we could see ourselves from within, we would not find stillness but rivers. Capillaries branch like deltas. Lymphatic channels wind like tributaries. Neural currents spark across moist landscapes. Light refracts through plasma. Cells drift like coral in sailing lagoons. It would be an archipelago of motion, radiant and alive. Even in deep sleep, the cerebrospinal tide continues to move, turning thought into rhythm, washing away the residue of waking. Perhaps that is why sleep restores us so completely. It is the moment the ocean within returns to equilibrium. The body carries the memory of the moon. Our circadian and tidal rhythms share ancestry, guided by the same calcium and sodium ions abundant in seawater. The human clock, long before fire or calendar, was set by lunar pull. Even now, that pulse lingers, a faint echo of the tide within our cells. Morning water is not the same as evening water. Its charge, structure, and temperature shift with the light, influencing metabolism and mood. The self flows through phases like the moon, never static, always in motion. To understand this is to see that we do not possess water, it possesses us. We are patterns it assumes for a while, eddies in a larger current. When life ends, the pattern dissolves, but the water continues, carrying with it the trace of our chemistry and the resonance of our being. Every molecule has traveled through cloud, river, animal, and stone. Each drop we drink has been elsewhere, touched by centuries of transformation. To drink is to take in the memory of the world. We use water to describe emotion, because emotion is its movement made visible. Feelings well up, overflow, run deep. Anger boils, sadness drowns, joy ripples. These are not mere metaphors, they are reflections of physiology. Emotion rearranges hydration. To feel deeply is to shift the tides within. Sound too owes its power to water. Vibrations travel farther through liquid than air. When we listen to music, we feel it because our bodies are resonant chambers of fluid. A cello's low note stirs the stomach. A song's crescendo moves the heart. Whales use this same principle to speak across oceans, their calls traveling thousands of miles through salt water. Perhaps we respond to music because the ocean within recognizes its own language, the rise and fall of wave, the oscillation of tide. Just before sleep, when thought begins to blur, awareness drifts like a swimmer between surface and depth. The brain's waves slow, synapses loosen, and the cerebrospinal tide swells. Consciousness becomes fluid. The boundary between self and world softens. This is the threshold all myth remembers, the river one must cross between life and death, waking and dream, ignorance and knowing. Water marks every passage, because it is transformation itself. The ocean within us is healer as much as memory. When wounded, the body summons water to the site. Swelling is the arrival of repair. When fever rises, sweat cools the surface. When infection comes, lymph flows to cleanse. Water responds to imbalance with motion, restoring order. It is messenger, physician, and prayer combined. Even thought can heal through its influence on flow calm the mind, and the channels clear. Peace literally changes the way water moves through cells. We are whirlpools of liquid in charge, held together by balance. In the depths of the planet, water shapes stone. In the depths of the body, it shapes thought. Both rely on pressure and release, on the harmony of motion and pause. The earth's mantle and the human heart obey the same rule. To live, one must move, but not too quickly. Even the breath that fogs a mirror is proof of our participation in the planet's cycle, a cloud forming, briefly, before returning to air. Our exhalation may become tomorrow's rain. We are weather in miniature, our emotions the climate of our inner world. When the body dries, patience shrinks, empathy fades. Rehydration restores not only clarity, but compassion. To drink is to allow grace to return. The patterns water forms when freezing, branching, fractal, unique mirror neurons, rivers, lightning. It is the geometry of flow seeking balance. We find beauty in ripples and rain because we recognize ourselves. Water is paradox soft yet strong, yielding yet unbreakable. It can freeze, vaporize, dissolve, and still remain itself. It expands when it solidifies, preserving life beneath ice. It absorbs heat without changing much in temperature, stabilizing the climates of planet and body alike. The ocean within us mirrors these contradictions. We are fragile yet enduring, flexible yet whole. The miracle is not that water behaves so mysteriously, but that we do. A single molecule's journey could span a lifetime, entering through breath, flowing through blood, carrying thought, leaving as tear or vapor. Each carries a record of where it has been, vibrating with the imprint of its path. When we die, those molecules continue, joining air and river and soil, carrying us onward without sorrow. The boundary between life and death is porous. Water passes freely, unafraid. To understand the ocean within is to see life as motion, not matter. Every pulse, every synapse, every breath is a phrase in that endless conversation. When the water stops moving, life ends, but even then, it waits, ready for new form, new current, new possibility. This is why life returns after every extinction. Water endures. It remembers the shape of life and remakes it. Sometimes, in moments of stillness, floating in a lake, standing in rain, the border between inner and outer dissolves. The temperature equalizes. The sensation merges. For an instant, we remember there was never truly separation, only exchange. Children know this instinctively. They splash, play, and laugh in puddles without hesitation, at home in motion. Perhaps wisdom is nothing more than remembering what water already knows. Movement without fear, surrender without loss. Our ancestors revered water as sacred. Springs, rivers, wells, they built myths to honor the unseen truth that water is life's first and final vessel. To pollute it was to offend creation itself. Those old rituals of offering and blessing were early forms of ecology, gestures of gratitude. Today, we have forgotten. We treat water as backdrop, as commodity. Yet every drought and flood reminds us that control is illusion. Water collaborates when respected and resists when ignored. It withdraws to teach dependence, returns to teach grace. The ocean within us grieves when the ocean outside suffers. It is not metaphor, it is feedback. Even in a dying river, water hides beneath the surface, patient and persistent, waiting for memory to return. It knows that time favors those who continue to flow. We are not waiting for water to come back. It is waiting for us to remember. Every act of care, a cleaned stream, a saved drop, a moment of gratitude ripples outward. Because all water connects, kindness in one place becomes healing in another. The molecule that leaves your hand may one day fall as rain on another continent. The kindness travels with it. We are all drinking the memory of everything that has ever lived. Inside the body, this unity repeats. Each cell relies on the same liquid conversation. Hormones, neurotransmitters, and immune signals drift through blood like messages on a current. When flow is blocked, illness begins. When it resumes, health returns. Harmony is movement. To live is to circulate. To stagnate is to decay. In our most intimate moments, breath shared, tears shed, laughter released water binds us. We are not separate islands speaking across emptiness. We are waves overlapping. Even language travels through air heavy with moisture. Each word is a ripple. Each silence a still pool. True understanding is resonance, when our inner tides find rhythm with another's. Rain soothes us because it sounds like home. The brain's calmest waves mirror the frequency of falling drops. To walk beside the sea is to meet the mirror of our making. The horizon stretches endlessly, yet the sound of waves feels intimate, like our own breath magnified. The ocean within and the ocean without reflect each other. When we pollute one, the reflection dims. When we restore one, both become clear. Our task is not to master water, but to participate in its renewal. Every act of awareness is a form of cleansing. Science may continue to measure hydrogen bonds and quantum tunnels, and poets will continue to describe its mystery. But beneath all theory lies the simplest truth. We are what flows. Sit quietly and listen. The pulse in your wrist tells the story. It beats with the same rhythm as the tide. In that rhythm lies humility and strength. We are fragile because we are fluid, but fluidity is endurance. The ocean survives every storm because it yields, and so do we. The next time you drink, bathe, or stand beneath rain, pause to feel the communion. The water entering you is ancient perhaps, once part of a comet, a glacier, or a cell of another being. It carries the universe's memory of transformation. For a while, it becomes you. Then it moves on, continuing its pilgrimage through form. To recognize that continuity is to feel less alone. We are not separate lives surrounded by matter. We are expressions of one vast circulation. The ocean flows beneath everything, through everything as everything. We need only remember to listen. To leave Earth in thought is to rise through layers of blue, ocean, cloud, stratosphere, and then into the vast black where air thins into silence. From that height, the planet's shimmer fades into a single glint of sunlight reflected off its curve, a fragile brightness suspended in dark. The seas that once seemed endless now appear as a thin film wrapped around stone. Yet even as we ascend, we carry water with us, in breath and blood, in the quiet pulse of memory. The journey outward is never escape. It is continuation. It is water exploring itself. Beyond Earth's orbit, the light weakens, the cold deepens, but water remains. It changes costume. Liquid becomes ice. Vapor becomes frost. But the molecule endures, adapting like thought. The farther we travel, the more we see that oceans are not rare. They are recurring. They hide beneath crusts of ice, beneath dunes of methane snow, beneath the scarred faces of moons that circle worlds of gas and shadow. Europa is the first of these hidden seas, Jupiter's pale pearl streaked with rust-red scars. Its surface is ice, cracked and stretched by tides from Jupiter's immense gravity. Each orbit, Europa is pulled and released, kneaded like dough. That slow flexing warms its interior, melting the deep layers of ice into a world-spanning ocean. For years we doubted, then came the proof. Magnetic readings from Galileo, faint water plumes glimpsed by Hubble, small clues forming one vast picture. Beneath 20 kilometers of ice lies an ocean 100 kilometers deep, holding twice the water of all Earth's seas combined. That ocean is silent, lightless, yet alive with motion. Tides churn it, salts lace it, warmth seeps from a rocky seabed below. If vents rise from that floor, releasing energy into the cold dark, then the same chemistry that once woke life on Earth may stir there again. Imagine standing on Europa's frozen plain. The surface groans underfoot as fractures widen and close. Beneath, unseen waves press upward, whispering against the shell. The world breathes, and its breath is water. When Galileo's sensors first recorded that subtle magnetic pulse, the rhythm of a salty conductor, it was as if we had heard that breath for the first time. Oceans, it seemed, were not miracles. They were patterns. Farther out, Ganymede moon, larger than Mercury, shelters another ocean, layered like a gemstone beneath ice. Callisto, ancient and cratered, may hold briny pockets softened by ammonia, a natural antifreeze, keeping the deep from freezing solid. The Jovian realm alone holds more liquid water than the entire inner solar system. The void we once imagined as barren stone now glimmers with invisible seas. But Saturn's system holds the most haunting revelation. Tiny Enceladus, bright and smooth as a shard of mirror, hides a secret heart. For centuries it appeared ordinary, a frozen bead orbiting in the ring's glow. Then Cassini approached and saw fountains, jets of vapor and ice erupting hundreds of kilometers into space from fissures at its south pole. The spacecraft flew through them, tasting their spray, finding salt, hydrogen, organic molecules, the breath of hydrothermal vents. Beneath that crust lies a warm ocean touching a rocky core, alive with the same reactions that once fed life in Earth's abyss. Each plume is a revelation and a metaphor. Enceladus is giving itself away, grain by grain, ice crystal by ice crystal, forming Saturn's faint E-ring. It is a moon that nourishes its planet, offering its own ocean to the cosmos. If you stood upon its pole, you would see jets rising in the dim reflection of Saturn's light, freezing into snow before falling back. The ground would glow with frost, and beneath it the sea would press upward, ancient and patient. Every eruption is a heartbeat. Titan, Saturn's largest moon, is different again. A world wrapped in haze, its sky orange with methane. On its surface lie lakes of liquid hydrocarbons, black and reflective as oil. But beneath that exotic weather is another ocean, a hidden sea of water mixed with ammonia, hundreds of kilometers deep. Cassini's gravity measurements revealed the hint. Titan's outer shell floats upon something fluid. Titan, then, is a double world, an ocean above, an ocean below, separated by the crust of its own complexity. In Titan's atmosphere, methane behaves as water does on Earth. It evaporates, rains, fills lakes, and forms clouds. Yet the true ocean sleeps beneath, a water world encased in air, too thick to breathe. There, in slow darkness, chemical whispers may already be weaving the prelude to life. The realization reshaped our understanding. Water's desire to flow is not bound by warmth or sunlight. It adapts, finds niches, writes the same story on every scale. It can be glassy ice or boiling vapor, salted, acidic, alkaline, or laced with ammonia. But always, it seeks motion. The universe, we learn, is not dry. It is saturated with potential. When Cassini finally dove into Saturn's clouds, it carried with it the memory of those plumes, droplets from another ocean, data written in vapor. For a moment, water from Enceladus touched us, entered our instruments, our imagination. The boundary between worlds dissolved. The universe became one great circulation. Beyond Saturn, the story continues. Neptune and Uranus are called ice giants, though within them lie oceans stranger than any on Earth. Under crushing pressure and deep heat, water becomes superionic, half solid, half liquid. Oxygen atoms form a rigid lattice, while hydrogen flows freely through it, conducting electricity, generating magnetic fields that twist and wander. These are oceans without surface, churning silently in the dark. The same element that ripples through a puddle here conducts storms in a planet's heart there. The difference is only scale. Even Pluto, small and distant, shows signs of water's persistence. Beneath its heart-shaped plain lies a subsurface sea, kept liquid by internal warmth, and a crust of ice. When New Horizons passed in 2015, it revealed smooth plains and shifting ridges, marks of an ocean still breathing beneath the cold. Farther still, comets wander from the Oort cloud, frozen archives of the early solar system. When they near the sun, they awaken, exhaling vapor that glows across the dark. Each is a messenger from the cosmic ocean that seeded Earth. Now, with telescopes tuned to distant stars, we find the pattern repeating again. Thousands of exoplanets circle suns light years away, and among them are ocean worlds, planets covered entirely by sea. Their waters may stretch hundreds of kilometers deep beneath thick atmospheres of steam. There may be no land, only endless horizons, clouds dissolving into waves. On some, the ocean itself fills the sky, a seamless continuum of vapor and liquid, glowing faintly in alien light. A universe, it seems, prefers abundance. Where we once imagined rarity, we find repetition. Earth, with its delicate balance of land and sea, may be the exception, a bridge between barren rock and total water. On these aqua worlds, water is not a feature but a fate. It is the planet. The physics are the same everywhere. Hydrogen bonds stretch and break, capturing heat, sculpting weather, shaping magnetism. Molecules have no allegiance. Whether in a droplet on a leaf or in the mantle of Neptune, they perform the same dance, the choreography of connection. Water is the universe's way of recognizing itself. Astronomers have even found traces of water vapor in the winds of dying stars. As they cool, they exhale what was once locked in their cores, sending it back into the dark. The cycle closes and begins anew. Water forged in stellar fire returns to ice, to cloud, to ocean, to life. The universe drinks itself and dreams again. Perhaps that is why, when we gaze into space, we feel a strange nostalgia, not for a place, but for a process. We sense the motion that links us to the stars. Condensation, flow, evaporation, memory. The ocean beneath everything does not stop at Earth's shore. It continues outward, through moons and mantles, through comets and nebulae, through the hearts of planets we have yet to see. And always it asks the same question. If water is everywhere, then where is life? Maybe life is not an exception to water's story, but its expression. Maybe the act of moving, of dissolving, of connecting, that is life in its earliest form. Every tide, every subglacial current, every molecule trading bonds is an act of endurance. The cosmos moves toward coherence because water makes it so. The search for extraterrestrial oceans is, in truth, a search for kinship. We are looking for ourselves, not in image, but in rhythm. Each drop elsewhere reflects the same longing that shaped us. When human ships someday travel between stars, they will carry water not only as supply, but as memory. In every tank will flow the same ancient sea that once fell as rain on stone, froze in comets, and whispered beneath icy moons. When it touches new soil, it will listen first, taste minerals, and remember. Between the stars, invisible clouds of ice drift through the interstellar dark. Gravity gathers them, warmth awakens them, and again the cycle begins. Star, planet, ocean, thought. Every world's first rain is an echo of that ancient recurrence, flame translated into reflection. Perhaps the meaning of exploration is not conquest, but remembrance. Every probe, every observation, is the cosmos awakening to itself. When Voyager crossed the heliopause and entered interstellar space, it still heard hydrogen's faint whisper, the ocean continuing beyond the sun. Even there, water spoke, and it will go on speaking. Stars will fade, galaxies will thin, but water will persist, frozen, waiting for another dawn. When warmth returns, it will melt again, and life will rise again in whatever form patience allows. We are temporary shapes of its flow, brief ripples on its surface. To see this is to feel belonging. Our blood, our clouds, our tears, All are instruments in water's endless song. The same molecular rhythm moves through oceans, through moons, through the veins of galaxies. The universe is not empty. It is fluid. And somewhere deep within that motion, consciousness glimmers like sunlight beneath waves. Because in the end, the ocean beneath everything is not something we find. It is something we are.